So the first thing that I'm going to teach you is laws of motion. The moment I say laws of motion, what strikes you is to talk about a force. Because anything which is in motion is force is responsible. So the first topic is force. Force is any agency which enables a body to be pushed or pulled or change its direction. To all the three. So force is an agency which changes the state of rest or uniform motion or direction, okay, which changes the state of rest or uniform motion. Something is moving, you want to come to make it stop, that's what is uniform motion. And you want to change the direction, something is going like this, you want to change, so you need to apply force. So force is basically an agency. So they say force is an agency to push or pull an object, or you can also, in either way it's alright, to push or pull, or you can define it as, or change it, however you define is up to you. That's what is force all about. Okay, so next is, this is about laws of motion is about all the three laws. So the first thing that we'll have to learn is about inertia. Okay, there is inertia is a general term. It's like you're sitting here, I'm trying to push you. Okay, I'm trying to push you. You won't move. You won't move. But because you will try to resist with your mass, beyond a point you will start moving. When my force exceeds your mass is not able. So inertia is always related to, in general, mass. The word inertia refers to always our mass, not the weight. It just refers to our mass. Okay. So then there's different kinds of inertia, such as inertia at rest. That is, if suddenly the floor is moving, your body will refuse to move. You will go back. That's like you're sitting in a bus. Okay, the bus is moving. The bus starts moving suddenly, and your body will refuse. The top part of the body will refuse to move, so it will go back. That's known as inertia at rest. That's called a tendency of the body to be at rest. The tendency to be at rest and not to move. That's called inertia at rest. So you know the example of when you're sitting in a bus, the bus suddenly starts moving, your body tends to go back, which shows that your body is resisting to move. That's known as inertia at rest. Then inertia of motion, inertia at motion, or inertia of motion, whatever, inertia of motion. Okay, if a body is moving, like you were sitting in the bus is already moving, and bus sudden break pota, your body tends to come forward because your body is refusing to stop. Yeah, so that is a tendency to keep moving. Tendency to be moving is what is called inertia of motion. It will refuse to stop. So that's an example. You know the bus stop. Okay. So inertia of direction. So inertia of direction is like this. If your father is bringing you in a car, say he's taking a right turn, your body will move towards the left. Yeah, because you're going straight. When suddenly somebody is taking a right turn, your body tends to move towards left to oppose the change. So then inertia is a tendency to travel in the same direction. Tendency to go in the same direction. So then because you have a tendency only to go in same, you are refusing to change, what happens when you turn right, your body turns towards the left. So then actually when in the curved road, if they are taking a right, your body moves against the centripetal force. Your body moves like this. The body moves like this. Yeah, your body is moving like this while the turning is like this, you know. So that's what is happening. That's about inertia of direction. These are the three inertias. It's a general thing that you need to know in life itself. Yeah. So then next is about Newton's law. Okay, is it law of Galileo's fallacy? Yeah, I think it's Galileo's law. Okay, then I'll talk. This is all general terms about inertia. Inertia is always a mass equivalent. So then it is a mass which is not allowing you to change the direction. It's a mass, but we don't call it as mass. We say it is inertia. This term inertia, by the virtue of the property by which the body resists any change. The property by which the body resists any change. Okay, this is the introduction on inertia. Okay, so then that examples you know. So let's go to next topic is about Galileo. Okay, Galileo என்ன சொன்னான் அப்படிங்கறத சொல்றேன் first. Actually in the earth, in the world part in the universe, the earth is rotating around the sun, the moon is rotating around the earth. So everything is, the earth itself is spinning, so everything is continuously moving. But Galileo சொன்னா everything is at rest. This is wrong. That's called Galileo's fallacy. So those days when initially started, Galileo said all objects are at rest. Natural state. Okay, that's wrong. It's wrong. Okay, it's a natural state of all objects is to be at rest, and you need an external force. You need an external force to push, to make it moving, to push and make it moving. Purida? This is what Galileo said. Then that's truly not right. Okay, so we know that all planets keep moving, and so then came this guy, who was that after Galileo, who's that? Aristotle, sorry. Okay, this guy called Aristotle. Okay, he came in and he said, no, Galileo, you're wrong. He's saying that's a fallacy, saying all objects will keep moving unless there's an external, unless there's no friction. You see, if there is friction, we are sitting here because of friction. If there's no friction, we'll all be moving, actually skating around. So, the natural state of every body, the natural state is to keep moving. Yeah? Only if there is friction, only in presence of friction, okay, presence of friction, the body will not move. So, that is when you need an external force. Yeah, that is when you need an external force which has to be greater than this frictional force to keep the body moving. Okay, so natural state of every body is to keep moving. But if there is an external, there's a frictional force, the body will not move. In that case, you need to apply a force which is greater than the frictional force for the body. Are you clear? Yes. So that's the truth. Aristotle he identified Galileo's fallacy. Okay, that's called actually Aristotle's fallacy. Okay, I'm very confused. Okay, I think this is Aristotle's fallacy. This guy is Aristotle, and this is Galileo. I changed it around. Just make sure you're clear with it. Okay. So this is Galileo.
No, Galileo said is right.
Whatever Galileo said is right. Aristotle da romba pazhaya aalu. Ancient aalu is Aristotle. You can just, I am forgetting because you can start, it starts with the letter A, which shows that he must have been an ancient guy. We'll keep it like that because I am forgetting. So that is Aristotle's fallacy, and Galileo corrected it. Whatever Galileo said is right. Okay, then it goes to laws of motion. Yeah, okay, now it's Newton's law. Okay, even before that, Galileo did a lot of experiments. Let me talk about those experiments. Very interesting. He took an inclined plane. He allowed a body to roll down. He noticed that that the speed increased. The speed increases. The speed increases, which means it's accelerating. Yeah, it means it is accelerating. When speed increases, there is acceleration. It is accelerating. Okay. Similarly, you take an he took an inclined plane, and he allowed the body to go up the inclined plane, or come down an inclined plane. Say come down an inclined plane like this. Yeah. Speed, oh no, actually he actually made it go up an inclined plane. He noticed the speed is decreasing. Speed is decreasing, which means it's decelerating. Correct? Then therefore he conclude, so which means if it was flat, it will go with a uniform speed. So he's like making his own guesses. Okay, if we put a speed increase, if speed decrease, so then therefore he comes to a conclusion that the speed is actually when it's going up. You understand, when the body is going up, the speed is decreasing. When the body is coming down the inclined plane, speed is increasing. So then therefore he understood that if it's a plane, it will go with a uniform speed. There will be no increase, no decrease. In between he is coming to a conclusion. So what is the next thing that he is doing is he is taking an inclined plane like this, where there is a down and where there is an up. He allows the ball to come down. The ball rolls down here, comes here, go back and tries to oscillate. Nee or bowl la vandu or goalie pottu paru, it will keep oscillating. So then, but actually it doesn't reach exactly the same height. It reaches slightly below it because some amount is of heat is lost in the form of friction. Due to friction, it doesn't exactly reach the same height. It only tries to reach the same height. So what he did, he took another inclined plane where he is making it more flat, this slope. So then what happened, the ball came here and travelled a longer distance, wanting to reach the same height. Adukku try pannudhu. Okay, but it's not able to due to friction, but it tries. So then it tries to travel a longer distance. Therefore he'll conclude that if it was flat, the ball will go infinite distance, infinite distance in order to reach the same height, well it is not going to, but it continuously keeps on trying and ends up travelling a very long distance at a uniform speed. Very interesting inferences that he comes out with. Are you finding it interesting? Okay, இது வந்து பால் அந்த சைடும் அதே ஹைட்டுக்கு போகணுமா, அதுக்கு ட்ரை பண்ணுமா, ஆனால் போக முடியாது டியூ டு ஃப்ரிக்ஷன். ஸோ அது எவ்ரி டைம் இட் அட்டெம்ப்ட்ஸ் டு கோ மேக்ஸிமம் ஹைட். ஸோ ஸ்லாண்ட் பண்ணால் கூட இட் ட்ரைஸ் டு ட்ராவல் அ லாங்கர் டிஸ்டன்ஸ். ஸோ லாங்கர் டிஸ்டன்ஸ் போயாவது சேம் ஹைட் வரதுக்கு ட்ரைஸ். ஸோ எவென்ச்சுவலி ஹி கன்க்ளூட்ஸ் தட்ஸ் கோயிங் டு ட்ராவல் இன்ஃபினிட் டிஸ்டன்ஸ் வித் அன் யூனிஃபார்ம் ஸ்பீட். ஸோ தட் தீஸ் ஆர் த எக்ஸ்பெரிமெண்ட்ஸ் தட் ஹி டிட். It will never, but it is trying, and in that process it travels at an infinite distance. It travels with a uniform speed. Okay. So that's what generally happens. Okay, so then that's what he is trying to find out. Okay, these are all Galileo's various experiments that he is trying to find, see it's acceleration, this is deceleration, then in between there is a constant speed. Abdinala he is trying to inform. Okay, and there is also bringing in a component called friction. Okay, so then that's about these experiments, and then it's about I think it's about Newton's first law. Okay, it states that every body continues to be in state of rest or uniform motion along a same straight line, in state of rest or uniform motion along same straight line, unless an external force acts on it. Correct? That's what Galileo said, and Newton is also saying the same thing. What the hell? He is just copying everything from Galileo. Looks like it, correct? So every body continues to be in state of rest or uniform motion unless an external force acts on it. Yeah, uniform motion in a straight line, the same straight line, unless an external force acts on it. So, நீ உட்கார்ந்திருக்கனா உன்னை தள்ளணும்னா external force has to be there. So, that's what Newton is saying, that our body is already moving, it will continue to be already moving unless an external force on it. So, that's what it is. He is combining both of these. You know, and saying if it's something is already moving, yeah, Galileo said everything is moving, yeah, then external force necessary to stop it. If something is at rest, an external force is necessary to move it. So, it's possible for an object to be at rest or also in motion, and an external force anyway is necessary for changing its state of rest or uniform motion. That's what is Newton's first law. So, Newton's first law is about it's going to continue state of rest or uniform motion, and inertia that we discussed before is a biggest illustrator of Newton's first law. Correct? Body which is at rest continues to be tendency to be at rest, and external force is necessary to. Okay, so then these inertias are all examples of first law. Newton's first law kira da inertia varudhu. So what is inertia? Inertia at rest, inertia adla examples nariya sollalam. One வந்து பஸ் வச்சு சொன்னோம், inertia at rest க்கும் inertia of motion க்கும் பஸ் வச்சு சொன்னோம். அதில் கன்ஃபியூஷன் இல்லைல்ல உனக்கு. inertia at restனா it will continue to be at rest. அப்போ பஸ்ஸில் நீ உட்காந்துக்க சடனாக பஸ் கிளம்புதுன்னா your body will go back. Inertia of motion, your body will continue to move. So then when the bus is suddenly stopping, the body will go forward. So you understood the difference. Okay, so some more examples I'll give you for inertia of rest and inertia of motion. So supposing you have a carpet, you have so many dust particles in the carpet. You take the carpet, hang it and beat the carpet. The carpet moves, but the dust will resist to move.
Yes.
So what happens? The carpet moves, the dust is not moving, so the dust falls down. Okay, another example is you shake a mango tree. The branches move, but the mangoes resist to move. So then therefore the mango falls. It's because of the inertia of rest. Both these are examples of inertia of rest. And the bus example was an inertia of motion. So another example I can give you of inertia of motion is, supposing a person wants to take a long jump. He comes running and then jumps. Why? Because when he comes running, his body will continue to be in motion and he will resist to come to a rest, and therefore invariably he takes a longer jump, and that's what is happening in our Olympics. Yes. You understand?
Yes.
So that's about inertia of motion. So different examples, you know, for inertia of rest, inertia of motion, you kind of understood everything. And inertia of direction is, best example is the changing of the car's direction, where your body goes to the other side. So these are all the examples of Newton's first law, which is invariably nothing but inertia. Okay. So next let's go to Newton's second law. Newton's second law. What is Newton's second law? He said that the force is directly proportional to rate of change of momentum. Force applied. The force applied is directly proportional to rate of change of momentum. Change of momentum. Do you know what is a momentum means? Momentum means mass into velocity. Momentum simply means mass into velocity. So if a body has a greater mass, it will have a lesser velocity. If imagine a bigger ball will have a lesser velocity when you roll. Whereas a smaller ball when you roll, so you know that when a body's mass is less, the velocity will be more, and the mass is more, the velocity will be mass is more, velocity will be higher. Mass is less, the velocity is more. The mass is more, the velocity is less. The best example for this I can give you. Suddenly the word momentum came, so I am skipping the topic and going to what is a momentum. Correct? Obviously I have to explain to you what is that. A momentum is a product of mass into velocity, and the momentum will always remain conserved. You should know that momentum remains conserved. It remains conserved. What is the meaning of this remains conserved now? Okay, see, for example, or a rifle. Best example that I can give you is about a rifle, a big gun. Okay, this you can pull the trigger and the bullet comes out of it. Bullet has got a kutti mass, so it comes with a tremendously high velocity, and that is why it's able to pierce through our body. Yeah, because it will get half mv square the kinetic energy. It gains so much kinetic energy, it's able to pierce through. Whereas the rifle has got a greater mass. So, and should I say this as an example? No, I shouldn't say this as an example here. I would rather give some other example.
The ball example is
Huh?
The ball example, like I understood that.
Which one?
Ball.
Yeah, that was fine, right? I understand that you understood that. I'm trying to give an, okay, let's not talk about momentum being conserved in the second law. The second law doesn't prove that the momentum is conserved. Only the third law will prove that momentum is conserved. So all that second law says is, what is a momentum? Momentum is mass into velocity, and when the mass is less, the velocity is more, and mass is more, the velocity is less. You know the ball example, and you know that the force is directly proportional to rate of change of momentum, mv minus mu by t. What is this mv minus p final momentum minus p initial momentum? See, a body may have may be traveling with one velocity. This body may be traveling m1 with, it may be traveling with a velocity u1. Suddenly a force is acting on it. Suddenly you are putting a force on it. Its mass will remain m1, but the velocity will change to v1 because you are applying a force. Ekanve or body is moving, konja slower move adu, pudichu thalli vidu. So the same body is going to move with a greater velocity. So the velocity is going to change with the same mass, correct? It's m1 u1. This has become m1 v1. So this change, this is the initial momentum, and this becomes the final momentum. So the p final minus p initial, when you subtract, you get the change in momentum. Change in momentum. That divided by the time, the rate at which the change is happening, is what is equal to the applied force. Are you clear?
Yes.
So you know that in a single body, we are not talking about two different bodies. In a single body which has got mass m1 initially moving with the velocity u1, the initial momentum is pi. When its velocity changes, increases because of an applied force, it changes to m1 into v1. You know, there is a p final and a p initial, there is a change in the momentum, and that change in momentum by time, which makes it a rate of change of momentum, is nothing but the applied force. That applied force is directly proportional to rate of change of momentum. Are you clear? So very clear with this, and the example also is clear. Okay. Now I am going to give an, so just like in the first law, I spoke about inertia and I elaborated what is inertia and all before and gave you a lot of example. Just like Newton's second law, I am going to introduce a word called impulse. The phenomenon of impulse is completely attributing to the second law. அப்போ இம்பல்ஸ் அப்படின்னா நீ என்ன அப்படின்னு கேட்கலாம். இம்பல்ஸ்னால் என்ன அப்படின்னாக்கா, see supposing ஒரு பால் வந்து கையில் விழுது, catching the ball and move the, have you seen the ball is moving the hand because they are increasing the time so that the force on the hand becomes less. So then impulse is a product of force into time. Impulse is a product of force into time. When a bowler catches the ball, he increases the time so that the force on his hand is less.
Yes.
You understand?
Yes.
So this is about a bowler. This is about a bowler example. A bowler, adhe pari, if you are falling in the concrete floor, so the time of time is so low that the force is so high. This is when you fall fall on concrete floor. From the first floor lend gudi concrete floor ku. What is happening? The time is so time is less, so the force is more. So spinal cord odayudhu. But if you fall on a concrete floor, fall on a sand nagarum. When you fall, the time increases, so then the force decreases, so we don't experience much fractures when you fall on sand. So the impulse phenomenon is about how the time is increasing, the force is less, and the time decreases, the force is more. You understand? இதுவே ஒரு bowler வந்து இப்படியே வச்சு அந்த பாலை பிடிச்சானா கை சவந்து போயிடும். So that is why he does that. புரியுதா? So then another example that I can tell you is about a nail and a hammer. Nail and hammer. Okay, நீ சுத்தியில வச்சு ஆணி அடிக்கிறனா டக்குனு அடிப்ப. You are increasing the time so that the force is more. Okay, so then you are decreasing the time so that the force becomes more. I am sure all these examples you understand. What is this? This is about a bowler catching the ball. Catching the ball. And this is about when fall on the concrete floor, when you fall on a sand, the nail he being hit by a hammer on the wall. So you know all these examples and how impulse work and how you come across a new term called impulse. How is this related to Newton's second law? Okay, Newton's second law is rate of change of momentum, but impulse is force into time, which is mv minus mu by t into t. Force itself is mv minus mu by t. T and t get cancelled. So this is nothing but impulse. So impulse is also change in momentum. Impulse is also simply change in momentum, which is final momentum, which is p final minus p initial, which is mv minus mu. It's also force into time. So you know the same impulse can be expressed in two different ways depending on numericals. If they're going to talk about velocities, you'll use this. If they're going to talk about a direct force and a time, you can do that and do final impulse. The two different ways, and you can, and these impulses are all based on the phenomenon of Newton's second law. Okay, where the force is directly proportional to rate of change of momentum. Can you see F is proportional to m into v minus u by t, which also give you F is equal to ma, which you know force is always mass into acceleration. So you arrive at this F is equal to ma by means of Newton's second law. அதுதான் இதையே நமக்கு கற்றுக் கொடுக்கும். ஸோ நியூட்டன் செகண்ட் லா பார்த்தா நிறைய விஷயம் கற்றுக் கொடுக்குது. நியூட்டன் செகண்ட் லாவில் ஃபோர்ஸ் இஸ் டைரக்ட்லி ப்ரொபோஷனல் ரேட் ஆஃப் சேஞ்ச் ஆஃப் மொமெண்டம். நியூட்டன் செகண்ட் லா ஷோஸ் தட் ஃபோர்ஸ் இஸ் டைரக்ட்லி ப்ரொபோஷனல் டு m into a, force in mass into acceleration. அதுக்கப்புறம் நியூட்டன் செகண்ட் லா ஆல்சோ gives rise to a phenomenon called a new phenomenon called impulse, which is force into time. Therefore impulse itself is as only change in momentum. அது மாதிரி நிறைய வந்து you are able to think in depth. No, this is what gave rise to the first law gave rise to inertia. Okay, second law gives rise to a new phenomenon called impulse. And there are different ways in which you are able to express things, and so you'll be able to relate. Or someone that the impulse பத்தி பேசுறனா இல்ல you're talking about impulse in terms of change of momentum or impulse in terms of force into time. அப்படி ஒண்ணா நீயே question பண்ணிட்டு you will be able to answer. So that completes this. Okay, so that's about impulse. And I'm going to talk about supposing a constant force is applied. A constant force is applied. Okay, the impulse will be just force into time. This is force graph and time graph, and impulse itself is force into time, which is merely the area under this rectangle. Force into, which is area under the graph. So area under a force time, therefore you know that area under a force time graph gives you what? Impulse. Because force into time is impulse. So the area force into time L into B.
It will give the
Area which is giving you a impulse. So then therefore you understand that area under a force time graph directly can give you impulse. So ஒரு graph கொடுத்துட்டு impulse கேட்டா கூட you can find the area under the graph and get. So impulse கண்டுபிடிக்க எவ்வளவு மெத்தட் இருக்கு. எப்படியெல்லாம் உங்க क्वेश्चन கேட்கலாம். They can give you graphs. Mostly they give you graphs and ask you to find something or other. So you know that when you give a force time graph, you can find the impulse using finding the area under the graph. Yeah, finding an area under this graph is so easy. So supposing this is a constant force. There can be force which is also like this, which is increasing linearly. Then you can find the area under this by using area of a triangle. But what happens when it is a non-uniform force? That's when you're going to have a problem. So this is a constant force. Now we're going to come across a non-uniform force. A non-uniform force is the one where the force graph, force time graph will be like this. So you have to find the impulse, which means you have to find the area under the curve. You can't find area under the curve by you like area of rectangle or area of triangle. So you have to divide it into a infinitesimally small rectangle with a width delta t or dt, because this is t, x-axis is t. X-axis la ஒரு குட்டி width na dt, a change in d. Pertaining to which the force is f nu vechukko. What is the area of this rectangle? Is f into dt. You get the area of this rectangle?
Okay.
Yeah.
Yes, ma'am.
F into dt gives you area of rectangle, and supposing this is t1 and this is at a time t2, by integrating this from t1 to t2 you can calculate what is impulse. By integrate, when you integrate, the dt will be integrated from t1 to t2,
Yes.
and the whole, you can calculate the whole calculation. That's what integration is all about. I hope you learned differentiation and integration.
Yes, ma'am.
You did. So this is how integration is when it comes to a non-uniform motion. You want to find the non-uniform force, you want to find the impulse, you have to calculate it like this. So that's about the impulse graph of it. Okay, so and that completes Newton's second law. Yeah, that is done and dusted with Newton's second law, because impulse is what is mainly to do with impulse, Newton's second law. The last is Newton's third law. Newton's third law. Okay, what is Newton's third law? Every action has an equal and opposite reaction. Every action has an equal and opposite reaction. This is Newton's third law. So supposing between two bodies, this is not one body. Either வந்து ஒரே body தான் we applied a force and its velocity changed.
Yes, ma'am.
But இங்க வந்து is about two different bodies. Okay, so you have a body A, okay, and you have a body B. Okay, body B. அது ரெண்டும் மோதிக்குது, or இப்படி மோதிக்குது. Okay, and then you will see that they will move in the same direction like this. This is m1, this is mass m2, initially moving with the velocity u1, this is moving with velocity u2. After collision, this is during collision. After collision, A will continue to move like that because it's bigger mass, no?
Yes.
And rebound avadu.
Yes.
So then this is m2 and this is m1. The m1 is going to acquire velocity v1 and m2 is going to acquire a velocity v2. And so then you know that the force on A, மோதிக்கும்போது there will be a force on A due to B and a force on B due to A. There will be the force on A due to B and a force on B due to A. அப்படி இருக்கும். ஆனால் ultimately இந்த force ரொம்ப கம்மி. இந்த force ரொம்ப கம்மி, அதனால இது டைரக்டாக இப்படியே போக ஆரம்பிச்சு ரைட் சைடே போயிடுது. புரியுதா? So you therefore you understand that the force on A due to B is equal to minus of force on A due to B, because according to him every action has an equal and opposite reaction. If the big one is going to exert a force on this, there will be a same kind of force which is exerted by the small one on that one அப்படின்னு சொல்கிறோம். So then actually speaking அப்படி பார்த்தா the reboundல ஆனும் it's the same force அதெல்லாம் இருக்கு, but for now don't get into that aspect.
No support.
No.
I will not be there, you will receive it.
Yeah, I'll receive it. Okay. So then therefore force on AB is equal to minus of force on BA, correct? BA, but that doesn't. Okay. 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 So what is force on AB? Force on AB is rate of change of momentum, right, of A. Rate of change of momentum of the body A, which is mass is m1, final velocity is v1, minus m1 into initial velocity is u1 by t. This is all pertaining to just A. And let's talk about a body B, which mass is m2 and the final velocity is v2, p final,
Yes, ma'am.
minus p initial, yeah, m2 into u1 and v u2 u2.
Ma'am, there's M2 and U2.
Yeah, this is about the second body.
Oh, okay.
What this is about the body B. I saw mass has to be m2 only.
Okay.
And the velocities is initial velocity is u2 and the final velocity is v2 by time. So you get like this, the t and t gets cancelled. So you get m1 v1 minus m1 u1 is equal to minus m2 v2 plus m2 u2.
Yes, ma'am.
Correct? We take the negative side. Now you have to take everything to one side. Like what in one side? Energy before collision. You have to take the initial velocities together. This is one initial velocity. This is another initial velocity. You're going to take it to that side. So that m1 u1 plus m2 u2. is equal to m1 v1 plus m2 v2, which shows that the momentum before collision, sum of the momentum before collision is equal to momentum after collision. Can you see? Which shows that momentum remains conserved. Momentum remains conserved. People don't have brains when I say. Okay, you understand? So momentum remains conserved. So initial momentum is always equal to the final momentum. Since like nee nanu modikrom, I have a mass and I have a velocity. I have a bigger mass and I have one particular velocity. I am calling it as u1. Your velocity mass is m2 and you have a different velocity. Now modikitapram n velocity and velocity rendume change agum. Mine is not u1, it will become v1. Yours is not u2, it becomes v2. Appo you know the force on AB is equal to force on BA with a negative sign positive. You concluding that the momentum before collision becomes equal to the momentum after collision. But I have written before here and after here, that's only. This is a very very important inference that we come across using Newton's third law. ஸோ பார்த்தீங்கன்னா ஒரு லாலேருந்து ஒன்று ஒரு பியூட்டிஃபுல்லான விஷயங்கள் கிடைக்குது. ப்ராக்டிக்கல் லைஃப்பில் ரிலேட் பண்ணுற முடியவும் இருக்குது. புரியுதா? இந்த மொமெண்டம் கான்செப்ட் வந்து செம்ம இன்ட்ரெஸ்டிங்காக இருக்கும். ஓகே, ஸோ அ வெரி குட் எக்ஸாம்பிள் தட் வி லேர்ன்ட் இஸ் ஐல் டீச் யூ த சம்ஸ். ஓகே, ஒரு பாம் இருக்குது. ஓகே, அந்த பாம் வந்து ஸ்டேஷ்னரியாக இருக்குது. அந்த பாம் வந்து நம்ம வச்சுட்டு வந்துடுறோம். அது வந்து பர்ஸ்ட் ஆகிடுது. பர்ஸ்ட் ஆனப்புறம் என்ன ஆகுதுன்னா குட்டி குட்டி பீசஸ் ஆகிட்டு அது செதறி 4 டைரெக்ஷன்லேயும் போகுது. இட்ஸ் ஸ்ப்ரெட். வை? பிகாஸ் this momentum is zero because it does not have velocity. This is a stationary mass, stationary bomb whose velocity is zero. So initial momentum itself is zero. Appo final momentum has got to be zero only because momentum has to be conserved. So what it does is in the total mass m breaks down into m1, m2, m3, m4 and m5 having different velocities in different directions. This is u1 in this direction and u2 in this direction, u3 in this direction, which is opposite to this, so that this will cancel with this. So this momentum is a vector, this momentum is a vector, they will get cancelled. This momentum is a vector, this momentum is a vector, they will get cancelled. This momentum and this momentum get cancelled. So the net momentum therefore becomes zero. And the madri it will spread out in directions, and momentum itself is a vector. The momentum, where I have written about momentum, I started with momentum here, and you should know that the word momentum here, P, is known as a momentum, and it's a vector because velocity is a vector. Mass is not a vector, but velocity is a vector. So by different velocities in different directions getting cancelled out, the net momentum becomes zero. Beautiful. Physics is so beautiful. I can't tell you, it's so beautiful. Okay, so then that's about another example that we learned is our body is already the bomb is already moving. Bomb throw பண்றேன். Okay, so it's a moving bomb which is going to explode. Can you imagine? So then that is going to have an initial momentum. That is definitely one bomb with a greater mass which is going to have initial momentum, and it's going to burst, and bursting it's going to get split up into pieces. But it should have a final momentum which is equal to the mass into velocity of the bigger mass into velocity. Correct? Say for example this is going to break down into like this. So which means it should not get cancelled out. So it is not going to spread in different directions. It's going to go in one way and spread, so that nothing is getting cancelled. So then therefore this is m1 and this has got a velocity v1, this has got m2 and a v2 and an m3 and a v3. When you add up all this, that should be equal to capital M into v. Yeah. In fact there was one question where we'll deal with it breaks down into 3 fragments where 2 fragments have the same mass. Idu same mass. Okay, idoda mass kuduthruvan, idoda velocities kuduthruvan. These both will have the same mass and same velocity. Okay, so then say 30 meter per second, this is also 30 meter per second, will have the same mass and kuduthruvan. So idoda net momentum calculate panniralam. In the total momentum minus this will give you the momentum of this. You know the mass of this, and hence therefore you can find the velocity with which the third piece will fly. And mariela questions varum, puriyada? Are you finding it interesting? Okay, is this the way your teachers taught you in that class?
Not with this example.
But they covered all this, whatever I covered, was it all there?
They finished till the third law.
Finished till third law. But did you get this kind of clarity anywhere? Oh, yeah. You understand the difference. Okay, so
There's online class, so I couldn't like concentrate thoroughly. So it's
concentrate at
offline,
all.
yeah.
Okay. But even my online classes will be like this.
Yes.
But whatever I will say, I'll just draw and show you.
Yes.
All these examples you can visualize and you can understand. It doesn't matter whether it's offline or online.
Okay.
The concentration is something that comes because of interest only. See, whether you are sitting here or you are at home. If you are interested, you will listen. If you are not interested, you can't blame it on an online or an offline. Okay. It is basically you are not interested. If you have interest, you are going to listen. Okay, so don't blame it on online classes or all. Even for the teachers, for that matter, they are also. If you are not there, I'll be teaching to the wall. Then I will also not be interested. No. So what drives me is the interest for the subject. Yeah. So it is the interest that you have to blame it on, and never blame it on an online or an offline. It doesn't matter. You can learn it from globally anywhere. If somebody is knowledgeable, provided you have the inclination to learn. Okay. So then that's about this. Okay. This completes Newton's third law, and you know Newton's third law is applicable only for two different bodies. See, நானே என் கணத்தை அரைஞ்சிக்கிட்டேன் there should be an equal reaction எதிர்பார்க்க முடியாது கரெக்டா நானே என்ன தள்ளிக்கிட்டேன் it's not on the same body if I push you then I'll also go back you know it's like that okay if somebody is going to get off the boat ஒரு ஷோர் boat வந்து it's going to land in the shore இங்கே நிற்குது once it's landed now you want to get off the boat okay as you get off the boat you tend to push the boat backward the boat goes because every action has an equal and opposite reaction so this is one example of Newton's third law and the recoil of the gun so supposing there's a gun and the bullet comes out and since the mass and the bigger velocity and this is greater mass and this is a smaller velocity it is going to come back it's going to come back with the momentum and it might hit your shoulder shoulder you will hurt your shoulder because the mass of the rifle is so high so what you will do you see that soldiers will keep the rifle along with the shoulder so then when they keep the rifle on their shoulder you know this is the shoulder can you imagine this is going to be the shoulder I don't know there's a man here and that's his shoulder no there's a man here and the shoulder is there okay can you imagine he's keeping it there so that it won't come and hit his shoulder also thereby by keeping it he is adding up the mass of the rifle and the mass of the man together constitute a greater mass so recoil velocity will be very very less that's called a recoil velocity will be very very less so it doesn't hurt him otherwise நாம சுட்டுட்டு நம்மளே விழுந்துருவோம் புரியுதா so then therefore you should know if you're holding a big rifle you know not the small guns big rifles I'm not sure the small guns they shoot in movies like this only extending their hands it's got nothing to do with that but in the case of big rifles that used in the armed forces and all they keep it in the shoulder like this closer so that it doesn't hurt them because the recoil velocity that way will become less by increasing the mass of the man and the mass of the rifle the mass is huge and so the recoil velocity is this is another example of Newton's third law yeah so then that completes Newton's third law too so is there anything that I have left out okay oh so now I have to finish all the laws okay so then I have to teach you numericals on every law how are the numericals going to be asked based on every law okay so impulse can you see impulse diagram of impulse it's a constant force this is a variable force and so then let's look at the sums on impulse sums on impulse is very very important and sums of momentum is also very important sums on inertia na onum kediyadu first law base panni not you know first law is F is equal to m into a so you don't have to worry much about F is equal to m into a we'll concentrate more on whatever we are doing like the second law and the third law pertaining to that okay so let's look at the sum here it's page number okay I'll read out the sum for you it's in page number 5.12 in Aurora if you have the Aurora you can go back home I'm not writing the question a batsman hits the ball back in the direction of the bowler without changing okay there's a batsman the bat is here he hits the ball without changing its speed so then there's a ball which comes here and he hits it back without changing its speed அப்படியே at the same direction okay in the same direction which it came a batsman hits back a ball straight in the direction of the bowler போட்ட direction திரும்பி வருது without changing its initial speed. The speed at which the ball went is the speed in which the ball is going to come back. But you should know the speed in which it went is the initial speed, which is positive, but the speed in which it's coming back is the final speed, which is negative.
Okay.
Yeah,
Yes.
so it's minus u.
Yes.
So then that's the initial speed and this is the final speed. If the mass of the ball is here, the mass of the ball is mass of the ball is given to you 0.15 kg. Okay, determine the impulse. You know that impulse, mass and velocity are given. What is the formula you can use? It's P final minus P initial, not force into time. You use P final minus P initial, which is mv minus mu. Correct? And what is mv is 0.15 and u itself is minus u. Yeah, minus mass, which is 0.15 into u itself is u. And so if you want the impulse, if you know the impulse, your initial velocity, which is 12 meter per second. 12 meter per second is this velocity and minus 12 meter per second is this velocity. So you have already substituted, so it's minus 0.5 into 12 minus 0.5 into 12 will make it 2 times minus 2 times 0.5 into 12, correct? So then that's the answer will be, it's addition, it becomes addition but though with a negative sign. This will be 0.125, okay, let me copy the answer. So it's minus 3.6 Newton second. Oh, you should know that the impulse is force into time. So the SI unit is Newton second. Force in time is Newton second. So this is how you get, and this is what the answer is. So basically you should understand that ball going is u, the ball returning back is minus u, which is ball going is 12.6, the ball returning back is minus 12.6. So it's P final minus P initial. So which is P final is mass into final velocity v minus P initial mass into initial velocity u. So you know initial velocity is positive, so you put the mass and you put only 12, but here you put mass and you put minus 12. You understand?
Yes, ma'am.
So thus you get it added. Okay, so then that's about the first sum. So in the second sum, is the let's go to the 10th sum in the Aurora. At the same page, a cricket ball of mass 150 grams, which is for 150 grams is 0.15 kg. Yeah, mass 0.15 kg, moving with the speed of velocity is 15 meter per second, is brought to a rest by a player in 0.5 seconds. It's coming to a stop in a time of 0.05 seconds. In the time kudutale, okay, impulse force into time. So if you can calculate the force and you have the time, you can calculate your impulse. Moment they give, at that my mind will go to force into impulse formula. But do I know the force itself? I know the time. Do I know the force? But what is given is the velocity. So cricket ball of mass 150 kg moving with the velocity of already is moving. So this is your initial velocity. Is brought to a rest. So final velocity is 0. Calculate the impulse. I don't have to use this time. Do you think I have to use the impulse formula? The impulse formula would rise rather P final minus P initial. I know mass into final velocity minus mass into initial velocity, which is mass into final velocity itself is 0 minus mass into initial velocity itself is 15, and you know the mass itself is, so this becomes 0 and the mass itself is minus 0.15 into 15. That will give me anyway an answer of what is 15, 15s are 225. Yeah, a decimal placed here with a minus sign should be my impulse and Newton second. So I got the answer, but now I am thinking, I didn't use the time at all. Is there anything else that they are asking? Obviously they are asking for force. Obviously they must be asking for force.
We use everything that is given in the question.
They have given time, would they give it unnecessarily? So definitely they must be asking for the average force, not just the impulse. And you know that force is rate of change of momentum, mv minus mu by t. You already found mv minus mu, which is p final minus p initial by t, which itself is nothing but impulse by t. So when minus 2.25 by the time taken itself is 0.05. So when you have something like multiply both sides, numerator and denominator by 100. So it will become minus 225 by 5, and on dividing this you get minus 45 newtons. So are you clear? So let's go to the 11th sum in Aurora. A rubber ball of mass 50 grams falls from a height of 1 meter. A ball is falling from a height of 1 meter, which means its initial velocity is 0. It's going to hit the ground, and then we don't know what, but the ground, it's 1 meter. So with this you can find what is the velocity with which it's going to hit the ground, because you know v square minus u square is equal to 2as. So you know u is 0 and v is what you're going to find is equal to 2 into ball falling on the ground to acceleration is positive, so a g, which is 10, let's keep it as 10, into s itself is 1 meter. So therefore it becomes 20. So then v square is equal to 20, so v is equal to root of 20, which is 2 root 5, yeah, whatever is it. So then let's copy this answer. It is he's using a 9.8, doesn't matter. So you get your, I'll copy whatever is his answer. So what is his answer? Is he written anything? He's just written it as root of 9.6 left and like this. But v at least are better than that, so we found the v. That, imagine, is the velocity with which it's going to hit the floor. Then the ball is going to rebound. According to the question, the ball is going to rebound. It's going to rebound and going to a height of 0.5 meter, which means the final velocity will become 0, and you can find immediately the initial velocity using the formula v square minus u square is equal to 2as. You know, v itself is 0, s itself is 0.5, a it's 2 into 10, yeah. So then minus u square, hence you can find there will be, this is going up, so g will become minus 10. So minus and minus anyway get cancelled, thus you get u square is equal to minus 2 into 10 into 0.5, whatever is this calculated value. This is 5, 5 2s are 10, it can't be minus, and minus got calculated, cancelled, so u is equal to root 10 meter per second. Thus I know this is root 10 meter per second. Velocity which is going to go up, and the velocity which is going to incident is 2 root 5 meter per second. See, which means they are going to ask me the word called impulse, and impulse is always is what happens at the floor. Thud, the falling of time, you know. So basically the question must be only about this and not about all that. The question should be about impulse. And what is impulse? Impulse in general is always p final minus p initial. What is p final? The mass into this velocity, and p initial is mass into this velocity. The hitting and the rebounding velocity is all you need. You don't need the initial velocity at that and all. You need to know what is happening at the floor. The velocity with which it's hitting becomes the initial, velocity with which it's rebounding becomes your final. So p final minus, so it's mass into final velocity which is root 10 minus mass into initial velocity which is 2 root 5, and this difference will directly give me my impulse. And you know, the mass has been given, so we saw something like a 0.15, yeah, did we write it? I didn't write it, okay, there's a different sum, okay, a 50 gram ball, okay, what does 50 gram mean? 0.05 kg, correct? So then therefore you substitute 0.05 into root 10 minus 0.05 into 2 into root 5, and a subtraction of this will give you your impulse. So this is a question only about impulse, find the impulse and also average force in a time of 0.1 second. So once you found this impulse, you know that force is nothing but impulse by time, because rate of change of momentum by time. So take that impulse value 0.05 root 10 minus 0.05 2 root 5, you can take what is common and cancel and then find it, and the time itself is 0.1 seconds, which will give you your answer. So what will you do here, how to find? You will take a 0.05 common, and you will write root 10 minus 2 root 5, is it? Is it p final minus p initial? Is that what I did? Yeah, I did that. So this gives you a negative impulse. Can you see? Because a 2 root 5 is like root 10 minus root 20. Purida 2 root kupona 4 idol. So can you see that it's 5 4s are 20 and root 20 is greater. So you'll get a negative value of impulse. Yeah, the negative value of impulse just shows that the impulse is in a direction opposite to that of the incident ball. So the ball impulse is going to be from the ball, okay, in the negative direction. That's what it means. So they have not spoken anything. It's the opposite. The impulse is going to be the direction opposite to that. Okay, so then it's going to be in the direction of the force of the ball on the ball. Force exerted by the ball on the ball's direction. So that's what it means, that negative sign. It's not going to be in the incident direction. That's all it means. So you understood and how to resolve it, you know, but let's not get into calculation part. You just understand the sums and this enough. So let's go to next sum. Yeah. Okay, this is an engineering sum, AEEE. Okay, IIT JEE sum. Let's do this sum. So it's example 13. A machine gun fires a bullet of mass 40 grams. So then can you imagine a machine gun here? Okay, it's firing a bullet of mass 40 grams, which is what is 0.040, correct? Kg. Kutti mass. With the speed of velocity so high, can you imagine it's 1200 meter per second. Yeah, meter per second. The person holding the gun can exert a maximum force of 144 newtons. He is able to exert a force of 144 newtons on this. This force is what is going to get translated into the rate of change of momentum of this bullet, correct? Yeah, what is the number of bullets that can be fired from the machine? Oh, machine gun அப்படி சொல்றான். அப்ப நிறைய bullet போகுது. அப்ப in the force with which is going to hit is going to result in more number of bullets is going to fly. The trigger அவ்வளோ ஃபோர்ஸாக அவன் புல் பண்ணணும். அப்போ தான் வந்து அவனுக்கு அப்போ பேசிக்கலி மிஷின் கன்லாம் நம்ம ஆப்ரேட்டே பண்ண முடியாதுன்னு நினைக்கிறேன். So number of bullets going out should be more accordingly depending on the force. So you know that a force இங்கே டைம் எல்லாம் ஒன்றும் கொடுக்கல, per second தான் கொடுத்துட்டான். So no problem. Okay, what is the number of bullets? So per second போது அவனுக்கு வந்து force itself is rate of change of momentum, mv minus mu by t அப்படின்னு உனக்கு தெரியும். But in the time தான் 1 second ஆச்சு. So change in momentum itself will give you force in this sum. Okay, so you just have to calculate the change in momentum which will directly give you force, and the force is 144 newtons, and that is responsible for a change in the momentum which is so from the bullets which was the initial velocity 0 is now moving with the velocity of 1200. So the change in momentum of each bullet is mass into, okay, which is 0.040 into 1200, p final of the momentum, minus p initial which is 0. This is the change in momentum of one bullet. So n bullets is 0.040 into 1200. Thus you can calculate what is n. Number of bullets will be 144 by 0.040 into 1200. What is that going to result in? Let's calculate. It's 144 by 12 fours of 48, right? 12 fours of 48. So there will be a 48 here, and there are 3 zeros, yeah, and I have to keep a decimal before 3 zeros. Yeah, it just becomes 144 by 48, which shows that, can you see, 3 bullets. Okay, that's an IIT sum. Kids, I didn't do this in class. Please make sure that you are learning this sum. It's very interesting. Let's go to 14th. Okay, so a ball moving with a momentum of 5 kg. Momentum கொடுத்துறோம், PA கொடுத்துறோம், P initial கொடுத்துறோம், mass into velocity ல வேணாம், which itself is 45 kg 5 kg meter per second. 5 kg meter per second. Momentum is mass into velocity, so it's kg meter per second, obviously, correct? SI unit. Okay, so P initial is given. Strikes a ball. It's going to strike a ball. Or ball poi strike a ball, but an angle of 45 degree. So it's striking at an angle of 45 degree, and it's getting reflected at the same angle. So it's coming back also at the same angle. I'm coming back in a different color, also at an angle of 45 degree. You know, this is P initial. I'll write it in blue color. The P initial is written in blue color, and the P final is written in purple color, correct? So you have to resolve this in vectors. I'll do, you know what, when you have a vector like this in this direction, it can be resolved as like this and like this. Do you know that? Resolving of vectors? You know it now, okay?
Yes,
when there's something like this in this direction, you're resolving, you resolve it like this and like this. So this will be cos theta component. So Pi cos 45, and this will be opposite, Pi sin 45. Adjacent to the angle is always called cos 45 side, and opposite is sin 45. So this gets broken down. Anything which is crossed, if something is like this, I'll break it down into 2 components. When something is like this, I'll break it down into 2 components. So that is how we can resolve the components and solve physics, okay? So then therefore, which means you are not going to score in the next following exams and all. So when it comes to laws of motion, start scoring, because you don't know about the resolving itself. Okay, so that's something very, very basic. So you, it's obviously either you have not listened, or the teachers have not taught you properly. So then this is Pi, means it's Pi sin 45 and a Pi cos 45, and this is P final. You see purple color, how I'm resolving is like this and like this, and always this is Pi, this is P final, right? sorry, it's P final cos 45 and this will be P final sin 45. Are you clear?
Yes, ma'am.
இப்படி போச்சுனா இப்படி இழுத்து விடுறேன், இப்படி இருந்தா இப்படி போடுறேன். Okay, arrows are okay. Are you clear? So now I'm going to solve the vertical components. So you always solve it as components. Vertical component is this, that's a vertical component. Okay, so the vertical components I'm going to resolve and I'm going to find the impulse. Impulse along the vertical component along the y-axis is P final minus P initial, and you know that both of them are downward, which means both of them are negative, and the P final is this purple color. Yeah,
Yes, ma'am.
so it's P final sin 45 minus the blue color is also downward, so it's change minus of Pi sin 45, because there is already a minus sign and Pi is already downward, so it's negative, so therefore it's going to become plus. So then therefore it's P, if you know that the Pi and Pf is equal to P, they are saying it's going to go with the same momentum. Let's see, a ball moving with a momentum of 5 kg, it's given as 5 kg meter per second, strikes the wall and get reflected back the same angle. Calculate the change at the same angle. A ball moving with the momentum of 5 kg meter per second strikes the wall with an angle of 45, it is reflected at the same angle and also with the same momentum, it's not specific. So you should know that this is also definitely going to rebound at the same. So then therefore it is going to become, this is P and P only, it's not P final and P initial, it becomes just P.
Okay.
Yeah, because it's not two different values, it's just P, though I made it as P, you know, Pi is equal to Pf is equal to P. So therefore it's becoming 2P. Sorry, I did I write sin 45 here? Yeah, sin 45 here. So it becomes, both of them are downward, right? Why didn't I put a purple color as negative? The purple color is also downward and the blue color is also downward. So actually speaking, it is actually getting cancelled. A minus P sin 45, a plus a P sin 45 is actually getting cancelled, and therefore the net momentum on the vertical component is becoming 0. Whereas let's resolve the horizontal component. Okay, this is how we solve it. Everything in physics is based on components, you better learn it well now. So the horizontal component, if you see, is again it's impulse you're going to calculate. It's P final minus P initial. Okay, one second, hold on. Have we continued? Yeah, I think we got. So then impulse is P final minus P initial, which is horizontal component, and the P final is the purple color in the left direction, the horizontal. Can you see? It's Pf cos 45, which is basically P cos 45, and it's negative direction, so minus P cos 45. So minus P cos 45, yeah, minus, and the blue color is in positive direction, so plus P cos 45. P cos 45, therefore it's getting added. Can you see minus 2 P cos 45? So you know cos 45 is 1 by root 2, and so minus P into 1 by root 2 makes it a root 2 P, and it's a minus root 2 P. Yeah, which shows that the minus sign shows that it's the wall is going to exert a force on the ball. That's all. My throat is totally strained. I've been taking continuous classes. Okay, so then obviously next question, they given the time. Yeah. Okay, you know that the force and the impulse is the same, the time is for 1 second. Is that the sum I was doing? I'm looking somewhere else. No, they didn't ask, they only asked for the change of momentum, and it's just this minus root of P. And if you know P's value, you can substitute. Obviously you know P's value, which is 5 kg meter per second. So minus root 2 into 5. It's 5 root 2 basically. Where is the answer here? Yeah. Here can you see a 2 and a root 2 get cancelled, a 5 root 2, and so you will get whatever is the answer. You understood what it is. And can you see they will give you a graph like this, which will be force time graph, and I told you if you find the area under the graph, you will directly get the impulse. These kind of graph sums, an example sum in 15, page number 15, a graph sum is very, very important, very straightforward. If they ask you from 1.5 second to 2.5 second, what is the area, you can find the area of this rectangle. If they ask you from a time 2.5 to 3 seconds, you can find the area of the trapezium. Correct? Yes. Or you can add the area of the triangle plus area of the rectangle, whatever you want to do. How do you find the area, the height into this breadth? So like that you can corresponding answer. Please everybody go through the example 15. Now you click clear. So then make sure you follow Aurora. You are done with all the sums pertaining to second law, which is completely impulse பத்தி எல்லாமே அரோரால பண்ணிட்டேன். So next வந்து third law. Third law is about momentum. Okay, is about the bomb bursting. Is about the bomb bursting and yeah, here it is. The third law sums is going to come here. And see, I told you that the fragments, the one mass gets fragmented into 3 different masses and something like that. Okay, so you must learn the example 23, which is very important. Example 23, which is very important, where a body of mass 1 kg initially at rest. So bomb is not as at rest, which means the velocity is 0 and the mass is 1 kg. It's going to explode and break into a fragment of 3 pieces in the ratio 1:1:3. அப்படினா என்ன அர்த்தம்னா 1 plus 1 2 2 plus it's 1/5. This mass is 1/5. This mass is 3/5. Suppose the total mass is 1, it's 1/5 of 1. This is 1/5 of 1, this is 3/5 of 1. That's what the individual masses are. Therefore, since the total mass itself is 1, you know the mass of the first body is 1/5, the mass of the second body is also 1/5, the mass of the third body is also 3/5, because it's 1/5 of the mass, or total mass. So you found the masses and it's given that the 2 pieces of equal mass is flying off perpendicular to each other. This 1/5 and 1/5 is going to fly off perpendicular to each other, which means when this is going to burst, yeah, it's not moving but it's just bursting. It's going to burst into 2 masses which are traveling perpendicular to each other. So a mass here and a mass here with an angle of 90 degree. Yeah, and this is your 1/5 mass. Yeah, and this is also a 1/5, which is your mass. And let's see the velocities. It's going to travel with a velocity of 30 meter per second here also. Since I have called this as V, I have to call this as V1. I am not calling it as U. Okay, so then this is V1 and this is V2. Both of them are 30 meter per second. You know the initial momentum is equal to 0 and the final momentum has got to be 0, and you don't know where the third mass is, but you know the third mass is 3/5. So keep it like this. There is some third mass somewhere here, we don't know, whose mass is 3/5 and whose velocity you don't know. So this question is about this. The question is about this mass, and you know that you can add up this and this should give you equal to 0. So then it's 1/5 into 30 plus a 1/5 into 30 plus a 3/5 into V should give you is 0. So with this you can calculate what should be your V. புரியுதா? So then இந்த மாதிரி வந்து ஒரு ஏற்கனவே மூவிங் பாம் பற்றி படிச்சு சொன்னேன். அந்த சம் எங்கே இருக்குதுன்னு I don't know. It's not I'm not able to see now. Yeah, but you understood that this is the way it works. Whether it's a moving bomb or a static bomb, this is the way it's going to work. So you are clear with momentum, you are clear with when they give you a graph, how to calculate the area. So mostly they give you these kind of graphs. They don't give integration, non-uniform force graph they are not given. The exams, if you see, even in your last exam, you had questions only like this, so you don't have a problem. So next is about says these sums and all is done. These are all Newton impulse sums, which are basically Newton's second law based. Yeah. So next, Newton's third law பொறுத்த வரைக்கும், you know, every action that only conservation of momentum, which is also conservation of, this also involves conservation of momentum, which means we are dealing with impulse also and also conservation of momentum. Correct? So both of them have been answered. So we'll go to the next part of the lesson. This till here it's one part of the lesson. Okay, so the second part of the lesson is about, you will come across normal. இப்போ நான் வந்து ஒரு பாக்ஸ் வந்து ஒரு டேபிளில் வைக்கிறேன். அப்போ there will be a downward weight, there will be a weight mg downward, it's called the weight, and every action has an equal and opposite reaction. Therefore there has to be a normal reaction straight above the head. So நான் இப்படி இருக்கேன்னா என் தலைக்கு மேலே ஒரு நார்மல் ரியாக்ஷன் இருக்குது, என் வெயிட் டவுன்வர்ட். இது கன்சிஸ்டண்ட்டாக நீ ஞாபகம் வச்சுக்கோ. ஓகே, தலைக்கு மேலே போடுறது நார்மல் ரியாக்ஷன். ஓகே, ஸோ சப்போஸ் இது இன்க்ளைன் பிளேனில் இந்த பிளாக் இருந்துச்சுன்னா தலைக்கு மேலே தான் நீ நார்மல் ரியாக்ஷன் போடணும். You can't put it like this. Though the mg is going to be downward, the normal reaction எப்பவுமே தலைக்கு மேலே vertical. Are you clear? Or perpendicular to the plane, or in other words perpendicular to the plane. அதோட நான் வந்து தலைக்கு மேலே அப்படின்னு யோசிச்சுட்டு இருக்கேன். அது எனக்கு ரொம்ப கன்வீனியண்ட்டாக இருக்குது. mg is acting downward. ஸோ இது வந்து நார்மல் சுச்சுவேஷன். ஓகே, இப்போ mg இப்படி இருக்குன்னு வச்சுக்கோங்க. If mg is going to act downward, okay, you should extend this normal reaction like this. Okay, and mark this as theta. அண்ட் திஸ் இதுக்கு ரெண்டு காம்பனண்ட்டாக பிரிக்கணும்னு என்ன சொல்லி கொடுத்துருக்கேன், இப்படி ஒரு லைன் இப்படி ஒரு லைன். ஸோ திஸ் இஸ் எம்ஜி காஸ் தீட்டா, பிகாஸ் காஸ் தீட்டா பக்கத்தில் இருக்குது. திஸ் வில் பி எம்ஜி சைன் தீட்டா. இந்த காம்பனன்ஸாக பிரிக்கிறது ஃபஸ்ட்டு கிளியராக கற்றுக்கோ, இல்லைனா யூ வில் பி வெரி அன்சக்ஸஸ்ஃபுல் இன் ஃபிசிக்ஸ். அண்ட் நார்மல் ரியாக்ஷன் அப்படி இருக்குது. நார்மல் ரியாக்ஷன் நான் பிரிக்கல, ஐ ஆம் ஒன்லி செக்ரிகேட்டிங் எம்ஜி. தேர்ஃபோர் யூ see here r is equal to mg இந்த கேஸில் ஆனால் இந்த கேஸில் r is equal to mg cos theta. கரெக்டா? அப்போ mg sin theta என்னவா இருக்கும்னா, இந்த பிளாக்ல வந்து இது சப்போஸிங் இஸ் கோயிங் ஸ்லைட் டவுன் வச்சுக்கோயே, there will be frictional force in this direction. So this mg sin theta will be countering the friction. புரியுதா? If it's going to accelerate, the mg sin theta will be greater than friction. If it's going to come down, you should know that mg sin theta is greater than f. So mg sin theta minus frictional force will be responsible for mass into acceleration of the block in this direction. புரியுதா விஷயம்? திருப்பி சொல்லி தரணுமா இந்த விஷயத்தை? புரியுதா? ஓகே. சப்போ இதில் வந்து இப்படி ஆக்சிலரேட் ஆகிருக்கு. சப்போஸ் வந்து ஒரு பிளாக் வந்து மேலே போடுறேன்னு வச்சுக்கோயேன், இப்படி இருக்கு, இந்த பிளாக் வந்து I'm going to move it upன்னு வச்சுக்கோயேன். எப்பயுமே நீ நார்மல் ரியாக்ஷன் தலைக்கு மேலே நார்மல் ரியாக்ஷன் போட்டுருவேன். அண்ட் எம்ஜி எப்பயுமே வெர்டிகலி டவுன்வர்ட் பிகாஸ் கிராவிட்டி இஸ் புல்லிங் இட். அப்போ இதுதான் ரெண்டு காம்பனண்ட்டாக பிரிய போது. இங்கே தீட்டா போட்டுட்டு இந்த இடத்துல எம்ஜி காஸ் தீட்டா போடுவேன், இந்த இடத்துல எம்ஜி சைன் தீட்டா போடுவேன். இதில் எந்த மாற்றமும் கிடையாது, எல்லா அசம்ஷனும் இதே தான் போடுறேன். பட் இதில் வந்து it's going to slide down. This is going to accelerate in this direction. What did I say? Oh, acceleration in this direction is over. So it's going to accelerate in the other direction. So basically, the block is going to accelerate in this direction. Okay, if you're going to accelerate in that direction, it means you're going to put a force in that direction. So frictional force will be in this direction. But frictional force will be always opposing. So then there will be a frictional force in this direction, correct? So when you applying you accelerate in that direction. So therefore you know that so this r is going to be equal to mg cos theta, no doubt. R is equal to mg cos theta. But this mg sin theta and the frictional force is in this direction. Okay. Because the body is getting, I am applying a force in this direction. If I am going to apply a force in this direction, which is going to be responsible for this acceleration, the frictional force will try to pull it down. And so what happens is you have to add the frictional force and the mg sin theta. Can you see, add the two components? So you get fr plus mg sin theta should be equal to your applied force. புரியுதா? அந்த மாதிரி டிஃப்ரெண்ட்டாக கான்செப்ட்ஸ் வரும். இந்த கான்செப்ட்ஸ் வரும்போது சொல்கிறேன், பட் யூ அண்டர்ஸ்டாண்ட் வாட் ஐம் சேயிங். ஸோ இதில் பொறுத்த வரைக்கும் இதுதான் அப்ளைட் ஃபோர்ஸ். திஸ் இஸ் அப்ளைட் ஃபோர்ஸ் விச் இஸ் mg sin theta மைனஸ் ஃப்ரிக்ஷனல் ஃபோர்ஸ். ஸோ ஸ்லைட் டவுன் ஆகும்போது அப்ளைட் ஃபோர்ஸ் எவ்வளோ கம்மியாக இருக்குது பாரு. ஆனால் ஸ்லைடை பார்க்கும்போது அப்ளை ஃபோர்ஸ் இஸ் மோர் பிகாஸ் யூ ஒர்க்கிங் அகேன்ஸ்ட் கிராவிட்டி. இந்த விஷயம் நான் திருப்பி சொல்லித்தரேன், உனக்கு புரிஞ்சுதான்னு எனக்கு டவுட்டாக இருக்குது. சரி, நார்மலாக ஒரு ஃபஸ்ட் லைன் சொல்கிறேன், ஒரு டேபிள் மேலே ஒரு, ஏன்னா இதில் நீங்கள் புரிஞ்சுக்காட்டா போக போக நமக்கு ரொம்ப கஷ்டமாயிடும். அதுலேருந்து அந்த இந்த மாதிரி தான் இதனால தான் பர்ஃபார்ம் பண்ண மாட்டேன்றீங்க. முதல்ல சொல்லிக் கொடுக்கும்போதே ஒழுங்காக புரிஞ்சுது ஆனால் புரியல அப்படின்ற மாதிரி இருக்கும்போது புரியலன்னு கேட்டு கற்றுக்கிட்டேன்னா அடுத்தடுத்து உனக்கு ப்ராப்ளம் நல்லா புரிஞ்சுட்டு தான் இருக்கலாம். நானாக சந்தேகத்தில் சொல்கிறேன். ஸோ யூ ஹாவ் அ பிளாக் லைக் திஸ். The mg will be directly downward and a normal reaction will be directly upward. அதே இது இந்த பிளாக் இப்படி இருந்துச்சுன்னா, ஐயோ நான் நார்மல் ரியாக்ஷன் எப்படி போடுவேன், mg எப்படி போடுவேன் தவிக்காத. mg is always downward and the normal reaction is like this only. ஸோ இதில் mg வந்து ரெண்டு காம்பனண்ட்டாக பிரிக்கலாம், which will be a theta here போட்டுட்டு நார்மல் ரியாக்ஷனுக்கு எதிர்க்கு mg cos theta and இந்த இடத்துல mg sin theta. இப்போது இந்த பிளாக் வந்து எப்படி மூவ் ஆகுது அதை வச்சு தான் கணக்கு. இந்த பிளாக் வந்து நீ கீழே மூவ் பண்ணணும்னு ஆசைப்படுறியா, இப்போ கீழே மூவ் பண்ணுறேன்னா இப்படி இருக்குது, இந்த இடத்துல ஆக்சிலரேட் ஆகுது. இப்போ கீழே மூவ் பண்ணுறேன்னா அப்போ ஃபோர்ஸ் வந்து இந்த டைரெக்ஷனில் இருக்குது, கரெக்டாக? ஆக்சிலரேஷன் டைரெக்ஷனில் ஃபோர்ஸ் இருக்குது. அப்போ ஃப்ரிக்ஷனல் ஃபோர்ஸ் எந்த டைரெக்ஷனில் இருக்குது, இந்த இடத்துல இருக்கும். இட் வில் ட்ரை டு ரிட்டார்ட். திஸ் இஸ் ஸ்மால் எஃப் ஷோஸ் தட் இட்ஸ் ஃப்ரிக்ஷனல் ஃபோர்ஸ். ஓகே, ஸ்மால் எஃப் ஷோஸ் தட் இஸ் அ ஃப்ரிக்ஷனல் ஃபோர்ஸ். ரெட்டாகவும் மார்க் பண்ணிருக்கு, டேஞ்சர் ஃபோர்ஸ். ஸோ தட் இஃப் இட் ஹேஸ் டு ஆக்சிலரேட் டவுன் which should be greater, mg sin theta should be greater than the frictional force, correct? So mg sin theta must be greater than the frictional force, so that mg sin theta minus frictional force will be resulting in a mass into acceleration or the net force which is pulling it in that direction, which is lesser. Can you see? But adhe block if you are going to make it accelerate upward, we're going to make it accelerate upward, which means the force is also in the upward direction. You know that the frictional force, which is a danger force, is going to happen in this direction. This is where the frictional force is, and you as usual do your normal reaction, which is like this. You as usual do your mg, which is like this. You as usual mark this as theta and mark this as mg cos theta and your mg sin theta, and you see the vectors are, you know, if it has to accelerate up, okay, this force has to be greater than these two. You have to add up these two forces. So therefore you are adding up mg sin theta plus the frictional force, which has to be equal to the applied force in order to, so then therefore which makes it the applied force greater when you are sliding it up, and the applied force is becoming lesser when you are sliding it down. That gives you justification as why the force is, you need to apply a greater force மேல் தூக்கிறதுக்கு, while a small சும்மாவே சரிக்கு வந்துடும், நீ ஃபோர்ஸே அப்ளை பண்ண வேணாம், தொட்டாலே புரியுதா இந்த விஷயங்கள் எல்லாம் புரியுதா? So you understand what is a normal reaction in mg and how it is drawn in terms of vectors when it's sliding. Okay, now coming back to this day to day life, I'm going to talk about நடக்கிறது. How are you walking? We are able to walk because there is a friction. Friction இல்லைனா we can't walk. So we are pressing our feet. அந்த காலை இப்படி விரலை வச்சு இப்படி அமுத்திட்டு தான் முன்னாடி போகிறோம். ஸோ அந்த விரலை இப்படி முன்னாடி வைக்கிறோம்ல, இப்படி விரலை முன்னாடி வச்சுட்டு அழுத்துற, அப்போ உங்கள் லெக் இப்படி ஆகுது. ஒன் ஆஃப் த லெக், ஒரு லெக் ஃப்ளாட்டாக இருக்குது, எனக்கு வரையெல்லாம் தெரியல. ஸோ ஒரு லெக் ஃப்ளாட்டாக இருக்குது, இன்னொரு லெக் இப்படி வளைஞ்சிருக்கு. Can you see I'm pressing a force?
Yes, ma'am.
And that results in a normal reaction like that. You know, every action has an equal reaction. So this becomes my normal reaction, and coronal irukadnala I should have two components. One is this is theta, this is r cos theta, and obviously this will be my r sin theta, and the r sin theta will counter the mg and this r cos theta is responsible for moving forward and overcoming the friction, because the friction is going to pull it backward. It's not going to let you move, and so then therefore the r cos theta is what is going to help you move forward, and the friction is a necessary evil. அப்படி சொல்லுவாங்க, கேள்விப்பட்டிருக்கியா? friction is a necessary evil. ஏன்னா அது ஃப்ரிக்ஷனுங்கிறது கெடுதலும் கூட. டயர்லாம் வந்து தேஞ்சு போயிடுது, கெட்டு போயிடுது. ஆனால் மனுஷன் நடக்கிறதுக்கு காரணமே, அப்போது டயர் தேஞ்சு போகிறத விட நமக்கு ஃப்ரிக்ஷன் ரொம்ப யூஸ்ஃபுல்லாக இருக்குல்ல. பட் ஆனால் நமக்கு ஃப்ரிக்ஷன்னால எங்களுக்கெல்லாம் வயசாக முட்டு வலி, முதுகு வலியெல்லாம் வருது. That's because of again friction. So there is an advantage of a friction and a disadvantage. That's why it's called a necessary evil. Okay, so then that's about it. This diagram is useful to you, and thus you understand that because of this normal reaction only you are able to propel forward. Now forget about friction or not. Just an example. Just is able to, இவ்வளோ தான் இருக்கும். mg கூட சொல்ல மாட்டாங்க, இவ்வளோ தான் சொல்லுவாங்க. The r cos theta component is able to make you move forward. However, you know r sin theta counters mg, and the r cos theta has to be greater than the frictional force in order to move forward. இது மைண்டுக்குள்ளே உனக்கு தெரியும், அதெல்லாம் இப்போ பேச வேணாம், அதெல்லாம் அவனும் பேசியிருக்க மாட்டான். இவ்வளோ தான் அவன் எக்ஸ்பிளைன் பண்ணிப்பான், அது போதும். This is an introduction. This is just an introduction. Why about our friction? How friction helps you to walk. How normal reaction helps you to walk. Rather, it's not the friction, it's only the normal reaction, and the normal reaction comes because of friction. Friction இருந்தால் தான் இந்த applied force இருக்கும். So then they are all interrelated. Can you see? So then that's about it. And so let's talk about horse and cart problems. Horse and cart problems. Okay, suppose ஒரு கார்ட் ஒன்று இருக்குது. இந்த கார்ட் இப்படி இருக்குது, இதுக்கு வீல் இருக்குது, அண்ட் இந்த கார்ட்டை வந்து ஒரு ஹார்ஸ் வந்து புல் பண்ணுது. இதான் ஹார்ஸ் வரையவா பேசாமல். ஓகே, திஸ் இஸ் ஹார்ஸ். ஓகே, வாழவாது போட்டு விட்றேன். அட்லீஸ்ட் குருவி கடைசி குருவி மாதிரி ஆகிடுத்தியா ஹார்ஸ். ஓகே, திஸ் இஸ் ஹார்ஸ். இந்த ஹார்ஸ் இஸ் கோயிங் டு புல் தி கார்ட். கரெக்டாக? இங்கெல்லாம் கயிறு போட்டு கட்டி வச்சுருப்பாங்க. இந்த இடத்துலையும் கயிறு போட்டு கட்டி வச்சுருப்பாங்க. இந்த கயிறுக்கும் இந்த ஹார்ஸுக்கும் இந்த ரெண்டுத்தின் நடுவில் ஒரு டென்ஷன் இருக்கும். ஏன்னா அந்த கயிறு வந்து பிடிச்சி இழுக்குது, ஹார்ஸ் பிடிச்சி கயிறு இழுக்குது, காற்று வந்து கயிறை பிடிச்சி இந்த பக்கம் இழுக்குது. ஸோ there's a tension, equal and opposite tension. So you call this as T and we call this also as T. And the horse வந்து is going to apply a force. We can call it as horse-ஓட force. H ன்னு வச்சுக்கலாமா? H is the force with which the horse is going to pull the entire cart and the rope and everything. And this is the tension which is prevailing here. Okay, and there is in the cart, idoda mass வந்து horse oda mass is small m, but cart oda mass is capital M. And you know that the force, why can't we keep it as capital F? Why should we keep it as H? Let's keep it as capital force, which is the net force with which the horse is going to pull. அப்படி வச்சுக்கிறான். ஸோ தென் யூ நோ தட் this is the capital M, this is a small m, and the force will be equal to a capital mass into A plus a small mass into A. So then force therefore is A into capital M plus small m. Thus you can find the acceleration A is equal to capital M plus F by, if you know the force with which the horse is pulling the entire cart, if you know the two masses, you can find the acceleration of the system, which means that will be the acceleration of the horse also, that will be the acceleration of the cart also. You get a common acceleration, obviously it's one unit, so it's going to have a same acceleration. So the first step is to find the acceleration. If you know the force with which the cart is getting pulled, you can say A is equal to F by capital M plus small m. Okay. Then once you find the acceleration, you can multiply this acceleration with this mass to get the force of experienced by force imparted by this cart on the rope. You know the acceleration of the cart, you know the mass of the cart, so simply multiplying the mass and the acceleration of the entire unit, you get the force imparted by the cart, force imparted by cart, which will be equal to this tension. Yeah, this is considering that there is supposing there is a frictional force, considering there is a frictional force in this direction, then T minus F in that case. If there is a frictional force, then acceleration anga nadakudhu, appo edu adhigama irukano, T has to be greater than F. So you know, considering this free body diagram, in the diagram la you know that adu eduthirren, okay, you understand that T has to be greater than F, for resulting in T minus F should be equal to capital M into A. Okay, actually they will put this as H, let me retain this as H for now. So this is H and this is H, whatever, yeah, just H, it's okay. So you know that here it's going to accelerate rightward, which is what has to be greater than what? If you take this free body diagram, H has to be greater than T. So if you take the right diagram, you know H has to be greater than T. So H minus T should result in a small m into A. So thus you get a first equation and a second equation, and you can solve it. Can you see, we can add the two equations, a 1 plus 2, a T and a T is getting cancelled, and you get a H minus F is equal to small m into A plus capital M into A. Yeah, H minus F is equal to A common capital M plus small m. So A is equal to H minus F by capital M plus small m. In the absence of external force, in the absence of frictional force, it will be just F by M plus M. That's what I did here. Actually, I took this as in the absence of external force. So I should not be doing that. First we will consider in the presence of frictional force. Correct. So then you should do like this only. There is a frictional force. Therefore, it's H minus F by M plus M. Are you clear? So இதை வந்து நீ மக்கப் பண்ண வேணாம், இது புரிஞ்சுக்கோ எப்படி ஃப்ரீ பாடி டயக்ராமை சால்வ் பண்ணும். இதை எடுத்துக்கிறோம், T minus F is equal capital into MA. இந்த இடத்துல ரைட் சைடு எடுத்துக்கிறோம், ரைட் சைடில் என்ன எடுத்துக்கிறோம், H minus T is equal to small m into A. ஸோ அந்த ரெண்டு ஈக்குவேஷனும் சால்வ் பண்ணும்போது you will be able to find what is acceleration. இந்த ஃப்ரீ பாடி டயக்ராம் வித் லெஃப்ட் சைடு, இந்த ஃப்ரீ பாடி டயக்ராம் ரைட் சைடு தனித்தனியாக நம்ம எடுத்துக்கிட்டு தான் பண்ணணும் அப்படிங்கிறத ஃபஸ்ட்டு தெரிஞ்சுக்கணும். ஸோ தட்ஸ் அபவுட் horse and cart problem, and you got whatever, because he kept it as H. I don't want to confuse you by keeping it as capital F, but actually it's a force, the force exerted by the horse, ultimate force. Okay. Okay, next இது முடிஞ்சிச்சா, இது வந்து this completes the horse and cart problem. இந்த மாதிரி நிறைய ப்ராப்ளம்ஸ் வரும், அப்புறம் பார்க்கலாம். ப்ராப்ளம்ஸ் சொல்லிட்டு I prefer saying sums, நிறைய sums வரும், அப்புறம் பார்க்கலாம். ஏற்கனவே ப்ராப்ளம் நிறைய இருக்குது லைஃப்பில். Okay, next is about lift. I'll teach you what is happening in lift. Okay, லிஃப்ட்டில் என்ன நடக்குது. சப்போஸ் வந்து ஒரு லிஃப்ட் இங்கே இருக்குது. ஓகே, இது வரைக்கும் செம்மையாக புரியுதா? ஏதோ கொஞ்சம் கூட உன் பேர் what is it? அனிக்ஷா. ஓகே, ஸோ லிஃப்ட் இருக்கு, லிஃப்ட்டில் ஒரு ஆள் உட்காந்துருக்கான், ஆள் இருக்கான். யூனோ லிஃப்ட்டோட நார்மல் ரியாக்ஷன் இஸ் கோயிங் டு பி அப் அண்ட் லிஃப்ட்டோட எம்ஜி இஸ் கோயிங் டு பி டவுன். இதில் வந்து வெக்டர்ஸ்லாம் ஒன்றும் கிடையாது, ஸ்ட்ரெயிட்டாக இருந்தால் வெக்டர்ஸ்லாம் கிடையாது. R and mg. If this, suppose this lift is going to accelerate up ன்னு வச்சுக்கோயேன், which has to be more? R has to be more than mg because it's going to accelerate up. So then R minus mg should be equal to m into a. Therefore R itself is mg plus ma. Yeah, this is the final answer that we got. Okay, let's talk about a lift that's going to go down. Yeah, and the normal reaction is still upward only, mg is still downward only, but the only difference is lift is going to go down, which is greater than what? an mg has to be greater டக்குன்னு சொல்லணும் mg has to be greater than r அது full concentrate பண்ணா தான் டக்குன்னு சொல்ல முடியும் so mg has to be greater than r so mg minus r is equal to m into a therefore mg minus ma is equal to r therefore you see r is equal to m into a plus g in this r is equal to m into g minus a yeah correct r is equal to mg minus ma yeah and let's talk about another case where the stationary lift is stationary which means r will be equal to mg so r is equal to mg in the different cases பார்க்குறோம் okay so இதுல என்ன தெரியுதுன்னா suppose நீ இங்க வந்து ஒரு weighing machine வைக்கிற okay நான் இங்க வைக்கிற weighing machine இங்க weighing machine வச்சு அது மேல நிக்கிறேன் இங்க weighing machine வச்சு அது மேல நிக்கிறேன் weighing machine வச்சு அந்த ஆளை அது மேல நிக்க வைக்கிறேன் அப்படி வைக்கும்போது இந்த normal reaction இருக்குல இந்த normal reaction can you see that it's more so apparent weight of the man will be more that normal reaction becomes the apparent weight of the man the weighing machine will show greater weight நீ இந்த லிஃப்ட்ல வந்து கீழ weight வச்சினா மேலே போச்சுன்னு வெச்சுக்கேன் உன் weight வந்து உன்னோட ஒரிஜினல் weight-ஓட அதிகமாகும் கீழ போகும்போது உன்னோட weight வந்து ஒரிஜினல் weight-ஓட கம்மியா இது appearing it's not true it's just appearing to be why because your normal reaction is lesser here the normal reaction is more here the apparent weight r is called apparent weight will be more here apparent weight will be lesser and here the apparent weight will be equal to actual weight so you get to see your actual weight obviously when this lift is stationary no
Yes, ma'am.
okay so what happens next case what happens when the lift is having a free fall na a will become equal to g you know acceleration will be equal to acceleration due to gravity appo a will become equal to g na r is 0 r is equal to mg minus இந்த condition தான கீழ வருது condition அந்த ஃபார்முலால இந்த ஃபார்முலால g is equal to a போட்டா r is equal to 0 mg minus a where g is equal to a shows that r itself is 0 so you will feel weightless நீ weighing machine ல பார்த்தா 0 காமிக்கும் உன்னோட weight அதிசயமா இருக்கும் free fall நம்ம எக்ஸ்பீரியன்ஸ் பண்றது இல்ல அதனால நமக்கு தெரியாது okay so that completes the lift are you clear with the lift issues okay எல்லா இடத்துலயுமே பார்த்தா அது பெருசா இது பெருசா அப்புறம் அது மைனஸ் எங்க மூவ் ஆகிறதுக்கு ஏற்ற மாதிரி புரியுதா ஓகே ஸோ தென் lift problems is over and conceptuals is over இந்த மாதிரிலாம் lift stationary ஆனது கேட்டாங்கன்னா நீ should be able to answer okay ஸோ அதுக்கப்புறம் lift முடிச்சாச்சு இதெல்லாம் முடிச்சாச்சு everything is done can you see இதெல்லாம் முடிச்சாச்சு ராக்கெட் வந்து போர்ஷன்ஸ்ல இல்ல ஓகே ஸோ நெக்ஸ்ட் வந்து equilibrium of concurrent forces ஓகே நெக்ஸ்ட் வந்து இதை எடுத்துறேன் புள்ளி எடுத்துறேன் ஆக்சுவலி equilibrium of concurrent forces அப்புறம் சொல்லித்தரேன் தேவையில்லை புள்ளி எடுத்துறேன் ஓகே நெக்ஸ்ட் வந்து சப்போர்ட் புள்ளியில் என்ன ஆகுது ஒரு சப்போஸ் ஒரு புள்ளி இருக்கு ஓகே அதில் இந்த பக்கமும் ஒரு வெயிட் இருக்குது இந்த பக்கமும் ஒரு வெயிட் இருக்குது சப்போஸ் லெட்ஸ் கன்சிடர் திஸ் இஸ் பிகர் வெயிட் லெட்ஸ் கன்சிடர் திஸ் இஸ் capital M and let's consider that this is going to accelerate downward obviously because this has got a greater mass and this has got a kutti mass kuttiya varairen so that you are clear it's got a kutti mass and it's going to accelerate up idukku irukna adu mele போகுது நல்லா புரிஞ்சுக்கோ இது வந்து இந்த ஸ்ட்ரிங்கை இந்த ஹார்ஸ் வந்து காற்று பிடிச்சி இருக்கும்போது இந்த ஒரு ரூப்பில் ஒரே டென்ஷன் தான் போடுறோம் ஆப்போசிட் டிரெக்ஷனில் அதே மாதிரி தான் இதுலேயும் இது ஒரே ரோப்பு தான் புள்ளிக்கு மேலே அப்படி போயிட்டு ஒரே ரோப் தான் வருது ஸோ இங்கே டென்ஷனும் ஷுட் பி தி சேம் புரிஞ்சுதா வேறு இருந்தால் தான் நீ போடலாம் ஃபார் எக்ஸாம்பிள் அந்த ஒரு பிளாக் ஒன்று இப்படி தொங்குது இந்த பிளாக்ல வந்து இதுதான் டென்ஷன் ஆனால் இதே பிளாக் வந்து இப்படி ஒரு ப்ரெஷர் ஃபோர்ஸ் போடுறேன் இப்படி ஆயிடுச்சுன்னா இந்த இடத்துல இருக்கிறது டி இந்த இடத்துல வந்து வேறு T1 and T2 in opposite direction இந்த பிளாக் இப்படி ஆகிடும் ஸோ ஒரு இந்த இடத்துல ஃபோர்ஸ் அப்ளை பண்ணலாம் ஸோ இது வந்து ஒரே த்ரெட் இதுவும் ஒரே த்ரெட் தான் நினைக்கலாம் ஆனால் நடுவில் ஒரு ஃபோர்ஸ் இருக்குது இதில் நடுவில் எந்த ஃபோர்ஸும் இல்லை புள்ளிக்கு மேலே போட்டில் எந்த ஃபோர்ஸும் கிடையாது ஸோ தேர்ஃபோர் it's T and T. It's going to accelerate you know that okay this is capital Mg. This will be capital M into G. This will be small m into A acting downward and it's going to accelerate down now this is greater than lifted. Mg is greater than T. So Mg minus T is going to result in okay capital capital mg minus t is going to result in capital M into a. Take the right hand side, which is greater. T is greater than ma because it's accelerating upward. So t minus ma is t minus ma should be equal to small m into g. Therefore, you get one equation and another equation. We can calculate what is t from both of this.
Yes, ma'am.
So it is mg minus ma. Elena, you can solve it like linear equation like before. Yeah, you can also do that. You can add this and this, so t and t gets cancelled. Yeah. So adding 1 plus 2, so 2 and t get cancelled. You get capital Mg minus small m into a is equal to capital M into a. I'm adding, right?
Yes.
Plus small m into g. Correct? So I'm going to consolidate and find acceleration, which means I'm going to take this to this side, take this to this side. So mg minus small mg is equal to capital M into a plus small m into a. So it's capital M plus small m, and this is capital G common, correct?
Yes, ma'am.
Capital G into capital M minus small m. Therefore, A itself is capital M minus small m into G by capital M plus small m will give me the acceleration. Let's see that if the answer is Stalin. Capital M minus small m, yeah, by capital M plus small m into G. That will give you the acceleration.
Yes.
Suppose they ask you to calculate this tension T, or this tension T. That's what I think they are doing. You know the acceleration. You can multiply it with the respective mass,
Yes, ma'am.
and that will give you the force exerted by the multiply equal to this tension. Correct?
Yes, ma'am.
What are they doing? Okay, actually speaking, you find A, you substitute in any one of the equations. You find A, you will find obviously your T.
T.
And the T is the same anyway.
Yes, ma'am.
Correct? Actually, don't say do what I said, because there is mg also involved. No, you can't just multiply with the mass and say that is the tension, because mg is also going to pull it down. So you have to substitute the A in this equation and arrive at a formula for T. So you don't have to learn it, you just have to apply this in sums. இப்படி சம் வந்தால் நீ இதை அப்படியே அப்ளை பண்ண போகிற அப்படிங்கிறது தான், புரியுதா? ஸோ நெக்ஸ்ட்டு வந்து இதை வச்சு நிறைய எக்கச்சக்கமான நியூமரிக்கல்ஸ் இருக்குது, ஒரு ஏகப்பட்ட நியூமரிக்கல்ஸ் இருக்குது. ஸோ சச் as this I have to teach you this also. Okay, so we'll go through. First வந்து புள்ளி நியூமரிக்கல்ஸ் முடிச்சிடலாம். புள்ளி இல்லையா, நியூமரிக்கல்ஸே இல்லை புள்ளி வச்சு. Okay, so this is all just a concept. Are you clear?
Yes,
So I'm going to do numericals for you after this. So it's like
Ma'am,
this.
I didn't inform parents when is the session?
What's the time?
12 minutes.
You came at 10:30 only, no?
Yes, ma'am. I don't know. I didn't report it yet.
Can you tell them 1 o'clock?
Yes, ma'am.
Yeah, you want to inform? You can tell them.
Yes.
Huh? வாங்க சார்.
சார் பொட்டி கேட்டாங்க, 2 பொட்டி இறக்கி வச்சிருக்கேன் மேலே இருந்து.
சரி.
அது இது பக்கத்துல மீதி நாளைக்கு மேலே
சரி. So then this is how we'll apply in the numericals. I'll give you extra numericals and you'll see how you are applying. Or even if they ask you sums like this, you'll know this is greater, it's accelerating like this. அப்படி போட்டு நீயே பண்ணிடுவேன். And sometimes they'll give you the tension, they'll give you you're finding acceleration here. Yeah, they might give you acceleration, they might ask you for tension. So you know you can substitute in mg minus t is equal to this capital M into a, and you can just substitute and find out. Like that you can do many sums. Okay, so a mass of a 6 kg is suspended by a rope. Okay, இதான் சொன்னேன் நான். ஒரு mass of a 6 kg is suspended like this. ஆனால் suddenly it's 2 meter length. Suddenly in between at 1 meter you are putting a force. ஒரு force ஒன்று அப்ளை பண்ணுறேன். அப்போ என்ன ஆகும், அந்த ரோப் இப்படி ஆகிடுது. So this is 1 meter, this will be another 1 meter, and the force will be in this direction. No, you have to extend it and put it in this direction.
Okay.
இங்கே போடுற ஃபோர்ஸ் அப்படி போய் அந்த பக்கம் போகிற மாதிரி. Okay, so there will be a tension here T, and there will be the block will be here, and I told you there will be a tension T1 and T2 equal and opposite. With the roof there is only one tension. Okay, with the roof there is only one tension, but here there is two tension. Okay, so can you see that this is the mass, and 6 kg is this, and there will be a mg which is 60 acting downward, yeah, and there's a T2 acting upward, and this is acting downward, and there is a tension here which can be resolved into components. Yeah, the question is 6 kg, a mass of 6 kg is suspended by a rope of 2 meters from the ceiling, a force of 50 newtons. A force of 50 newtons is applied in the horizontal direction at exactly the midpoint of the rope. What is the angle that the rope makes with the vertical in equilibrium? So they are asking the angle that the rope would make with the vertical, which means this is theta.
Yes, ma'am.
which means you put like this and mark this as theta, and this is t, right?
Yes.
So therefore the horizontal component, this is t cos theta, and therefore this will be t sin theta. You understand?
Yes.
Therefore the t cos theta will be equal to mg, and the t sin theta will be equal to 50 newtons. Are you clear? The t cos theta will be equal to t1 only,
Yes.
but the t1 is equal to t2, and the t2 is equal to, so directly we can write t cos theta is equal to 60. Therefore we can write t cos theta is equal to 60 and t sin theta is equal to 50. So dividing, you get tan theta to be 5 by 6. So immediately you got an angle at which it has theta, therefore is tan inverse of 5 by 6. You don't have to write the value, but this is how we resolve as components and find things.
Okay.
Okay, it's very, very important. Okay, next is let's do this this sum, where you have a wall and a ceiling, and you have a rope which is coming like this and a rope which is coming like this, to which a block is hanging. Okay, a block is hanging. The block is 4 kg weight. This is 4 kg weight, and you know that there is a tension which is T1 like this, and there will be a tension which is T2 like this, two different
Yes.
threads obviously. So then you can break this down into components.
Yes, ma'am.
Okay, so then the first thing we can do is, what is the question? Determine T1 and T2 in the strings. That's all is the question. Okay, so you know that this is making an angle theta here,
Yes, ma'am.
which means this will make an angle theta here, and therefore I can write this as T1 cos theta, and so then therefore I can write it as T1 sin theta. First, is it correct? Correct. So look at the way I am guessing the theta, and then arriving at a T1 cos theta and T1 sin theta. Okay, which are these vectors. Now come to T2. T2 doesn't have any components because it's a straight line. It does not have any components, right?
Yes.
So then what is that you are noticing is T1 cos theta should be equal to T2. For this to be in equilibrium, have they given? Oh no, it seems to be, because they are not saying it's accelerating. What, it can't, will it move?
Yes, no.
It can't move, so it has to be in equilibrium.
Yes.
So therefore you can say T1 cos theta should be equal to T2, and a T1 sin theta should be equal to 4.
Okay.
Correct? 4 or 40? 4 kg weight, so it's 40 newtons
Okay.
into 10, so it's 40 newtons. A 4 kg weight means it's 40 newtons, so is equal to 40. So then you know that T1 cos theta is equal to T2, and do you know what is T2? I don't know, but T1 sin theta is equal to 40. You don't know what is theta. Oh, they have given 60, is it? Oh, they given the question 60 degree. If theta is given as 60, there's no problem. You just have to substitute 60 here. So T1 cos 60 is equal to T2, and T1 sin 60 is equal to 40. You know what is sin 60? So T1 into sin 60 is root 3 by 2 is equal to 40. So T1 itself is 80 by root 3. That is your T1 in newtons. Correct? Tension also is 4, so newtons. You substitute that here, you will get T2. So T2 is equal to T1 cos 60, and you know T2 is equal to 80 by root 3 cos 60. Cos 60 itself is 1 by 2. So it will be 40 by root 2. You can rationalize and write the newtons, or you can write 1.414, and
Yes.
yeah, you can do whatever you want. Are you clear?
Yes.
So you understood how the component breaking is a very crucial thing without
Yes,
which
ma'am.
you have learnt laws of motion,
Yes, ma'am.
but you don't know any of these.
I can understand.
But you didn't get it clearly. Are you clear at
Yes,
least now?
ma'am.
Okay. So then let's go to next. What is so like this only we solve every sum. Though he has solved it differently, I would write it as a components. Look at this sum. I would write it as vectors. Okay, I'll do the sum in my way. I'm not going to do it his way. I'm going to do it my way. A ball of mass 1 kg hangs in equilibrium from. Okay. So then there's a roof. There is one thread here, OB. There is another thread here, an OA, and they are making an angle 60 degree and a 30 degree, and so OB and OA. What are the tensions in OA? So then it's hanging this like this. So a ball of mass 1 kg is hanging like this, and you know that the tension is T1. The tension here is T2. Resolve into two components. You know this is 60. Therefore you mark it like this and mark this is 60, and therefore this will become T1 cos 60, and this will become T1 sin 60. Correct? Okay, so let's go to this is T2, and you can resolve it into two components. So then therefore you can resolve it into two components. This is T2, this is 30 means this is 30, so this is T2 cos 30, and this will be T2 sin 30. Can you see that the T can you see that the T1 sin 60 and the T2 sin 60 are both in opposite directions. So you have to add them both, which will be equal to your mg. It's just 1 kg into 10. So then therefore what would you do? The T1 sin 60 plus the T2 sin 30 will be equal to your mass, which is 1 into 10, which is 10. So thus you get your, because it's a 1 kg mass, the question says it's a 1 kg mass, correct? So then next is, let's horizontal component. What is it? T1 cos 60 is equal to T2 cos 30. Yeah, you know the values, you can find the relation between T1 and T2. What is cos 60 is 1 by 2. What is cos 30 is root 3 by 2. So then 2 and 2 gets cancelled. So a T1 is root 3 times T2. You can substitute that here and you will get an equation and you can find what is T2. Correct. T1 badla root 3 T2 into sin 60 plus T2 into sin 30 is equal to 10. Abdin போட்டது மூலமா you know sin 60's value, sin 30's value, you get T2. Yeah, and you can substitute that, you can get T1. You can do wonders. Can you understand how beautiful is the resolving of vectors? So useful. It's so beautiful. You can solve every sum using resolving of vectors. Okay, so that completes this. And please, if you don't have Aurora, please immediately buy Aurora. So then that's pulley thing. I've taught you about pulley questions. Okay, let's come back to this kind of questions where let's come back to this question. It's example 38 in Aurora. Okay, where you have a block of 7 kg and it's placed on a surface. Maybe it's a smooth surface. That's what they mean by shading it. 50 newtons is applied to, or there's a rope which is tied to it, and a 15 newton is applied to this rope attached to a 7 kg block. Yeah, lying on a smooth horizon, smooth stable, so no friction. So normally I'll do this, no red color la. I shouldn't do it because there is no friction, and you know that there will definitely be a tension in the string. Yeah, and that tension minus, normally if it's accelerated, you'll say T minus F is equal to m into A, but F itself is 0. So T itself is 7 into A. So this is 15 newtons. A mass of 15 newtons is applied on a rope attached to 7 kg lying on smooth surface. The mass of the rope, there's a mass of the rope itself is 0.5 kg. So the total mass therefore is 7.5 kg. The total mass. And you know A is equal to F by m. The total force by, because there is no friction. So A is, when there is no friction, you can use the form A is equal to F by m. So F is 15 newtons by mass itself is the total mass, which is 7.5, which is acceleration is 2 meter per second square. That shows that the rope is also going to accelerate at 2 meter per second square and the block is also going to accelerate at 2 meter per second square. But the question is, what is the force exerted by the block on the rope? Okay, so it will if a 7 kg block and a 0.5 kg rope, the rope is going to exert less force on the block. But the block is definitely going to exert a greater force on the rope. So if you know the mass acceleration of the block and you know the mass of the block, you can multiply these two, which will be 14 newtons, and that will give me the force that is exerted by the block on the rope. The force exerted by the block on the rope will just be a multiplication of these two, which is 14 newtons. Are you understanding what I am saying? So the whole crux is to find the acceleration of the entire system, then write the respective acceleration wherever, and depending on the question you just solve. But there is no frictional force in this sum. If there was, then you should have resolved it as T minus F is equal to 7 into A. Yeah, you didn't have to do that because F became 0, so I could use the formula A is equal to F by M. Are you clear? Are you getting tired? No? Okay. So because I have to do a lot for you, okay, so then therefore you need to be necessarily motivated, okay. So then a wooden block of mass 2 kg is kept on the floor. A wooden block of mass 2 kg is kept on the floor, smooth, so no friction, okay. So we can do like this, so it's smooth, okay. When an iron cylinder, so initially you have a normal reaction and you have an mg. Mg will be 20 and a normal reaction, therefore R will be equal to 20 newtons only, okay. So then now you are taking this block, you are keeping the block over which you are keeping an iron cylinder, which is so heavy, iron cylinder, and the mass of the iron cylinder is 25 kg and this is 2 kg. So what happens total mass? 27 kg. Mass has to be added, no?
Oh, sorry, I multiplied, sorry.
Okay, so the mass, total mass is 27 kg, and you know what will happen the moment you keep this, He is saying the floor is yielding. What is the meaning na ரொம்ப weight தாங்க முடியாம floor கீழே போகுது. Okay, which means there is an acceleration in the downward direction, and you know mg is also acting in the downward direction, and that mg is 25 plus 2. That mg is 27 into 10, which is 270, because it's a total mass.
Yes, ma'am.
So there's an mg and the acceleration is happening in this direction, normal reaction is in this direction. So since acceleration down, what will you write? 270 minus r. Will you write that?
Yes.
At 270 minus r is equal to 27 into a. The total 27 into acceleration. So if you want to find a, it's 270 minus r by 27. What is your normal reaction? The normal reaction
20 newtons.
yeah, right. But with the block is placed here, would it be normal reaction will also be more, and it wouldn't it be 270? What am I saying? Okay, let's see what the question is and try to understand. So I did 27 plus 2 into 10, and I found that 270 newtons is the downward force. Yeah, and the normal reaction is a new r dash. You can't copy this.
Okay.
Because based on how much weight you are putting on the ground, the normal reaction is also going to increase. Appa na inga r dash podu 0 la varudhu, I have a problem here, correct?
Yes.
So I have to think about this, okay? So then this is normal reaction is r dash, and you know 270, which is downward force, has to be greater. 270 minus r dash should result in mass into the total mass, which is 27 into acceleration. And this to find this r dash, if you know acceleration, you can find. And they have given that it's accelerating at 0.1 meter per second square. It's given. So therefore you move it that side. You write 270 minus 27 into 0.1, which will give you your new r dash. When the floor is yielding, so you can ask me, auntie, you're saying how much weight you're putting down, that should be a normal reaction. But here it is accelerating down, no. So then the normal reaction is going to, when it's going down, the normal reaction will decrease. Remember that? It's going up, the normal reaction will increase, even the lift we came across. So then therefore your normal reaction has to be calculated by subtracting. It's less than 270 because it's decreased.
Yes, ma'am.
You understood? I hope you have that absolute clarity now.
Yes, ma'am.
Okay, so the 40th question, and the two blocks of mass m1, another block is m2, is being pushed in this direction by applying a force like this. The two blocks m1 and m2 are in contact with each other on a horizontal smooth floor, no friction. The blocks are pushed by a force. If the two blocks are always in contact, what is the force at the common interface? We are asking the force that is at the common interface. இங்கே என்ன force? உனக்கு நல்லா புரிஞ்சுக்கும். இந்த ரெண்டு block you are moving it from the left side. So which is a greater mass which is going to stop you from moving is this m2. So if you find the net acceleration, you can define the acceleration of this and this is common. You can take that acceleration, multiply with this mass, that will give you the force between m2 with m1, that will be the interface force. You should analyze what is the stopping force. The stopping force is idu move pandradhukku m2 is only ultimately blocking it.
Yes, ma'am.
So what you do is a is equal to f by m1 plus m2, because there is no friction, is a is equal to f by m1 plus m2. Yeah, you take this acceleration, which will be acceleration this also and this also, you multiply that in specifically with m2. That will be the force of the second block on the interface. Okay, so this is the force on the interface. Force on the interface. Okay, are you clear?
Yes, ma'am.
So then there is nothing given. There is no m1 and m2. It's all in terms of m1. No numbers. Numbers are not given. So let's go to the 41st question. Okay, there are three masses. So there is a mass m1 here. There is a mass m2 here, and there is a mass m3 here, and all of them are like this. And there's you know that there's the same tension which will prevail equal and opposite T1 and T1. There's the same tension T2 and T2, and there's an applied force here, and there is no friction because the smooth. When there is no friction, you don't have to worry about T1 minus F is okay. You know that if you want to find A is equal to F by m1 plus m2 plus m3. So you find the acceleration if you know all the masses. They are given that this is 5 kg, this is 10 kg, and this is 15 kg, and the force applied itself is 50 newtons. So everything you know is 50 by 5 plus 10 plus 15, 5 plus 10 plus 15, which is 30, is it? So 50 by 30, which is 5 by 3, which is meter per second square is my acceleration. That will be the individual acceleration of everything. This will also accelerate at 5 by 3 meter per second square. This will also go at 5 by 3 meter per second square. This will also go at 5 by 3 meter per second square. Okay. So if whatever they ask you, if you multiply the respective masses with this acceleration, you will get the tension T1. Because you know this free body diagram, there is no frictional force. So normally we will let T1 minus F is equal to M1 into A, but this itself is 0, therefore T1 is equal to M1 into A. So you take that 5 and multiply with 5 by 3, which is acceleration, you get the T1's value, which is 25 by 3 newtons. Now you take this, you know the acceleration of M2, and you know here it is, you see this T2 minus T1 is equal to M2 into A. You have to take this free body diagram. That will be slightly different. T2 minus T1 is equal to M2 into A. We already know T1 is 25 by 3, yeah, minus T2 is equal to M2's mass, you know, is 10 into A, you know, is 5 by 3. Thus, you know, T2 is equal to 15 by 3 plus 25 by 3, and thus you can find the tension in this. Yeah, which is 40 by 3 is T2.
Ma'am, isn't this 50 by 3?
5 by 3, no?
Ma'am,
Acceleration.
here's 10.
Oh, so that becomes, that's, what did I write?
You wrote 10 here, ma'am.
I wrote 15, it's 50.
Oh, sorry, yes, ma'am.
Okay, it's 50 by 3, correct?
Yes, ma'am.
Now is it okay now?
Yes, ma'am.
See, it's because this 10 is the mass,
Yes.
into acceleration is 5 by 3.
Okay.
So I should have written, I wrote 15, it's 50. Okay, I am trying to rushing it through for you because you can go through the video at home.
Yes.
Become thorough today.
Yes, ma'am.
Okay, otherwise we're not going to get anywhere. Okay, so don't go by a school, you go by my pace.
Yes.
Okay, இன்னைக்கு நீ நான் சொல்லி கொடுத்த வரைக்கும் முடிக்கணும்னா அரோரா வாங்க முடியுமா உன்னால?
Ma'am, yes, ma'am. I think I have, ma'am. My brother also studies.
Okay, so please make sure that you're very clear. Okay, and let's go to this kind of sums where if your parents have come, I hope they'll call you. You must tell me. There's a block here and there's a pulley here, and this comes from the pulley and there's another block here. Okay, and this is of a mass m1 and this is of a mass m2, and they're saying it's ultimately accelerating downward, which means that this will have an m2g, this will have an m1g in this direction, a m1g in this direction, and a m2g in this direction, correct? Obviously.
Yes.
Yeah, and there will be a tension here which is T, and there will be same tension T because it's running over the same pulley.
Okay.
So you know that you have to do it as a, there's no friction. The body of mass even places smooth table, so then smooth table there's no friction. Normally let T minus F is equal to M1 into A, but there's no friction, so you don't have to worry. So then you take this free body diagram, you know T itself is M1 into A. You take this free body diagram, it's accelerating right side. So then therefore it's M2G minus T. M2G minus T is equal to M2 into A. Okay, I have marked this in this direction. Do I even know whether it will come? Sometimes this can be such a mass, summa it can be hanging, it may not even accelerate. So you can't say that, but summa number போட்டுட்டு பண்றோம். If A becomes negative, we can say it's not coming down, something like that. Okay, so T1 is equal to M1 into A, and M2, take the two fluid body diagrams, there's no friction, actually it's T minus F is equal to M1 into A. Since friction becomes 0, it becomes T is equal to M1 into A. This free body diagram, M2G is equal to yeah, both of them are going with an axis. If this is going to pull it like this, it's going to pull it to the right. So it makes sense for you to write that. So you can substitute this T here. So you get M2G minus M1 into A is equal to M2 into A. If you want to find acceleration, is M2G is equal to A into M2 plus M1. So A is equal to M2G by M1 plus M2. Respective value, you get the acceleration of the entire system. The acceleration of this and acceleration of that. And you want to find a T, you can, if you know the acceleration, you know this mass, you can find the value of tension. How is it?
Yes.
So easy, right?
Yes,
Yeah, so let's go to 44th question. Okay, so then the 44th question, you have a fixed wall here to which a hook is connected, to which a pulley is connected, and a thread runs over a pulley and a force is applied here. You understand? So then therefore the block will also come forward. Correct? In the thread in the length the block will come forward. So this is the structure and this is the block. Can you see that if I am applying a force like this, I know tension along this is equal to tension along this. So if this is F, this is also got to exert a force F. And so this becomes the total force is becoming 2F. That's the advantage of having a pulley. The advantage of pulley is one place you put F, the other place there is also another F. So double the force is adding up. So it's able to come out easily. So then therefore it's 2F is equal to, there is a tension here, yeah,
Yes.
and that tension is equal to T is equal to 2F.
Okay.
So thus in this kind of sum you understand that T is equal to 2F, and as it comes there is no friction at all. So this tension is equal to this mass into A.
Okay.
Correct?
Yes, ma'am.
This tension T itself is equal to this mass of the block into acceleration which is happening in this direction. So if what is given, a block of mass, yeah, a block of mass 100 kg. So mass I am substituting. In motion, what is the horizontal force? Acceleration is given. So you find the tension. So this itself is 10 to the power 3 newtons, and you know tension. So 2F is equal to 1000. So F is equal to 500 newtons. Thus you know that the force you need to apply is only 500 newtons. Are you clear?
Yes.
That's the advantage of pulley. 5 newtons போட்டிருக்கானே. ஏய் மாஸ் தப்பா எடுத்துட்டேனா கிராம்ஸ் 100 kg centimeter. Acceleration is 10 centimeter per second square. So it's 10 centimeter per second square means, yeah, meter per second is 0.10. 0.10 meter per second square. So then therefore it is just it just stays as 100, 1000 and 10, is it? So therefore in substitute as 10 you get F as 5. Such a brilliant sum, yeah?
Yes, ma'am.
Okay, so that completes it. So here comes the sums that I was talking about, inclined plane when it's sliding down, you break that into components and you can try this sum, example 47 at home.
Yes, ma'am.
Okay, you know the concept? Yes, you know the
Yes,
concept, I
yes.
taught you the concept, same concept you're going to apply that. So that will give you so much clarity. After this it's a different topic, it's the third part of the lesson which is about friction and coefficient of limiting friction, static friction, banking of the road and all this, and this has to be another topic which we have to deal with another day. So then I'm just stopping the recording.